I would just ask you to keep your microphones off during the sessions. You can ask always questions during the Q&As after each session, and just raise your hands or write in the chat. And finally, in this session, break room sessions, we will ask you simply to join one of three sessions which will be given to you, and then in those sessions you will have moderators and online tools to give your feedback on specific aspects of our project. Just to put our project in some reference, under the Transnational Danube program, we are trying to improve energy security and energy efficiency by introducing promotion of renewables through our demo centers and show how to effectively manage energy distribution and storage. As for the relevance, you all know that renewable energy sources are very hot topic in this area, especially due to now even a more increase of the price of the energy, and that is why we want to show the various renewable energy sources in the grid, which can always be challenging through the many reasons. That is why we introduced this sector coupling model and try to somehow reflect it from the technical perspective to integration, which is basically a connection of production of mostly electricity with heating, cooling in industry and buildings through heat storages and several other technologies. Energy storage is also very helpful in this situation, where we can simply store excess of energy, especially in urban areas, which can greatly impact on energy production. Our aims are showed in this slide. The main objective is, based on what I said on the previous slide, is simply to update these energy storage and sector coupling solutions in different environments, since we know that the Danube region is different from country to country, from region to region. We are focusing on the mid-sized and smaller cities, not to only focus on the big cities, but also on these smaller ones. And how we will do it is through model solutions, which is basically calculator for you and online tool, and then show you other aspects as I told you. Last session today will focus on this build up knowledge and decision-making capacities of city actors, where we will show you good practices, and also to our partners from Romania, Lea, will dig up more into this regional action plans. Our project consortium is very big. That is why we also are expecting today high attendance. So far there is 41 of us, and I know that around 70 registered. Just as that, we also have a big project consortium, our 17 partners and 12 associated strategic partners. And our approach is, as I said, to break down this implementation of these technologies, these solutions, through several aspects. I will not go through all of those, as I have more specific slides to show. As of our demo centers, which is our next session, we have 4 demo centers. Very shortly about them: in Croatia, Austria, Slovenia, and Bulgaria. They are focusing on renewable energy sources, energy storage, and presenting of live data and all functionalities which goes along. As for regional action planning, which will be a separate session, we basically gathered a lot of data, provided some analysis of the data, provided some benchmarking studies of our target cities, which was probably shared with all of you. And now we are in the process of making regional action plannings, of showing our measures and implementing our measures in the legislation into trying to accelerate it in that area. Lastly, which will definitely be mentioned, is a joint roadmap, but I will not go through it except to say that it is Danube related document, which will basically show our comprehensive set of measures for each country. As for the session, as for the part of the project which is related to online tool, there was a very hard and excessive work from our partners to create all of the necessary steps that are shown in here to give you the tool where you will be able to input some basic data, and get some basic recommendations, but also in the last part of the project to provide you with more detailed technical and financial calculators. Training sessions are definitely of the interest to all of you, simply to raise the awareness and to get familiar more with this topic of sector coupling, but also with generally with energy sector. That is why we created financial and technical modules, adjusted those several times, and try to organize meetings with you, trainings with you. Some of your regions already had these meetings, and some of those will be in the future. Also, our main point of the meetings is, and of the training, sorry, is to put them on the online training and knowledge hub to give you constant, I would say, availability of these solutions. Lastly, from my side is Transnational Virtual Knowledge Hub, which is currently live. There will be a link on the next slide, but simply to show you what we try to do on this knowledge hub, not only to give you good examples of some projects and try to give you a bunch of deliverables, but simply to show you in a very interactive way our findings for each country, for each region, which workshops were organized, which trainings were conducted, and what we all learned from that. And from our perspective, we think that it is definitely a way of interacting with the results. On the other hand, which will be showed in the next sessions, is these demo centers, their data, and their I would say parts of projects which always were very important in terms of investments. So we really try to give a comprehensive reflection on that. As for our more informations, if you are interested in any part of the project more, you can always go to our website and our social media, but also on this virtual knowledge hub, which is officially published since the beginning of this year. I don't know if there is any questions on this side, in the general side. I'm happy to share it. I'm happy to answer all of the questions. If not, then we can go to the next slide and next session, which is a presentation of the demo centers, and then all of our demo sites in all 4 countries. I think that Cosmin, you are ready to to take the floor.
Yes, hello, thank you very much. I tried to share now my screen. If you can see my screen, can I start the presentation?
Yes, yes.
Okay, thank you very much. So I want to present you an overview of the demo investments, not going in details, just a brief overview, because after my presentation, our investing partners, each of them will present and to give you more details about their projects. And of course, at the end of the presentation, you can also have questions to them and they can directly answer to you. So as Marco said, in our project, we have CSSC lab project, we have 4 demo centers. The demo centers in Zaprešić, Croatia, in Stegersbach, Austria, and Desternik, Slovenia, and Varna, Bulgaria. And I go through each of them to outpoint some highlights. Starting with Stegersbach, we have a very complex system here with very state-of-the-art components and equipments regarding thermal storage for heat and cold, battery storage, also a salt battery storage, modern load monitoring and load management system. Also bring their charging infrastructures with pole charger and fast charger. At the end, this project is an energy positive office building and exclusively supplied with by renewable energy. It's currently operational. We can, I recommend it for visits where you can see the renewable energy technology, the whole potential, and it could be replicated and seen how it works. 2 lessons learned, or the main lessons learned in this project was that during the engineering phase, the proper dimensioning of the storage size and in the relations with energy demand, load profile, and the whole operation process. Also, the interactions between the different systems, PV and thermal storage, water flow, it was delicate, and after analyzing and recorded of parameters, interesting and useful knowledge are ready in a database where measured parameters have been have been collected and are permanent being measured. Going to Demo Center Varna, we have here an energy independent building with a modern PV system. It's connected to the boiler. It have a modern architecture using also battery capacity in a very modern mode and controlled mode. And the project was developed very quick, that you can see in my presentation that in January 2021, first data were also recorded and tested. The testing phase was started. For sure, lessons learned was here in this project, how the technical solution were integrated. Also, the consumption, the energy consumption was analyzed and hour by hour measured and tested. And also a very comprehensive database was established, and it could be used for further information. And of course, successful element, a factor in the process was the private organization which has developed this investment, and for sure they will give you more details later. And of course, they have a very good plan and process in the procurement. Take the best measures, so technical risk of the plant investment were successfully tackled. In Desternik, we have a PV system to electromobility. interesting the battery system, also the charging station, and of course the system is on the last phase to be ready to be operational. We have lessons learned here was that the risk of permission, it has been demonstrated it was high and was real, because during the implementation of the project, it was necessary that another location has to be chosen, and this led to delays in the development. But with the effort of our investing partner and in collaboration with the local authorities, the project goes further, and today the battery system is connected and in operation. Charging station is installed, and also now the works are just to be finalized for the software integration for the monitoring system. So it depends on the weather. The PV panels, the PV module is in work to be installed, and we are looking to be in the due time and to have the operation of the whole system and to integrate the components in March this year. Looking to Zapresic, we have a very complex and a very big project here because of the smart meeting solution for public building through the connection to the local district heating system. The solution combines solar thermal collectors, and here we had also a delay because the project was changed. The solution with solar thermal collectors on the roof was changed with a greater system to be installed on a green field. The main component, the innovative approach is that the main components integration of solar collectors, they can produce high temperature medium for local district heat system, and it's very challenging to give these parameters and to use it. Of course, we have here, because of this change of the project of the solution, we have a delay, but we are still in progress. The projects has to be finalized in this period, in period 4. Such we know that we are here. So the DHCon, the distributed heating company, invested until now in the distribution pipeline. The solar field was the option for over 3,000 square meter. Connections to the school and equipments are in progress. Also, heat purchase agreement, and yes, of course, it could be also helpful informations to look how the solution, the technical solution works, how the challenges, the barriers regarding heat purchase and also permissions have been solved. So very quickly, to let more time for the partners. Yes, this was my presentation, and I want now to invite my colleagues from Stegersbach, Michael Niederkofler, to present the investment there.
Yeah, good morning, everybody. Thank you, Cosmin, for inviting me. I will start sharing my screen. So, and I hope you can already see the presentation.
Yes.
Yes, as Cosmin said, I'm going to present the demo center in Austria, in Stegersbach. It's the Solar One building, which has been opened in October last year. And I want to give you some details on the planning period, the construction period, the implementation period, and also a little bit on the first events that we already have been able to hold here. I'd like to start with the timeline. The whole project started around 2018. I say around 2018 because the idea of building this demo center was already in the mind of our owner for quite some time, but the first plans started to get in concrete in 2018, and we started with the design work, which finished around the start of 2019, where we also started to specify all the equipment that would be used in the building. Then the first milestone was on the 26th of November 2019 with the groundbreaking ceremony, after which we started with the construction work and the equipment procurement. This was all mostly carried out throughout 2020. And at the end of 2020, in December, the first colleagues moved into the building. It looked more or less like on this picture. So the inside of the building was already finished, and the offices could be used. But as you can see, the outside, the parking space, charging infrastructure, and these kind of things needed to be finished with, which was done in the first half of 2021. By June 2021, we had all the equipment up and running, and the building and the demo center was opened officially on the 8th of October 2021. So what, of course, not the whole building is part of the CSSC lab project. The whole building was an investment of about 3.5 million euro. And only some parts of it are actually really the part also of the CSSC lab project. And the focus there, our focus there was the integration of different storage technologies. So it was the aim to show different storage systems in operation. We also wanted to integrate mobile storages, electric vehicles, charging infrastructure, in order to be able to demonstrate the sector coupling for electricity, for heat, for cooling, for mobility, and to have a lot of data generated interfaces between different storage solutions, and a load and flexibility management system to utilize the storages and the sector coupling as efficient as possible. So here you can see a diagram of the technical concept of the building. We have several PV systems in the building. We have different roof PV systems. We also have PV in the facade of the building in the form of building integrated photovoltaics. And we generate about 177 kilowatt peak of PV power here in the building, which is then utilized and also stored. So we have a lithium-ion battery, we have a saltwater battery for the storage of electric energy. Then we have sector coupling and have a heat pump system that converts the electric energy into heat or cold. We have then for the thermal storages, we have a hot storage and the cold water storage. Then connected to the whole system, we have the charging infrastructure for charging vehicles and utilize the generated energy also for mobility. And in the building itself, we have a lot of sensors of different kinds. We have temperature sensors, we have movement sensors, we have light sensors. so that in each room of the building, the heating and cooling is adjusted according to the utilization of the room, and so that we can also distribute the energy within the building as efficient as possible. And the last feature, important feature of the building is that the building core is activated. That means that the concrete structure of the building, the walls, the roof, the floor, they are all thermally activated by means of water pipes. And in summer, the whole building is used as a cold storage in this way, and in winter it is used as a warm storage, so that the building itself, the mass of the building itself, also acts as a thermal storage. So what about the planning? The basic concept of the building has been planned by us in-house, by Energiekompass GmbH. We are an engineering company, and we did quite a big part of the planning ourselves. The whole PV concept was done in detail by ourselves, but also the basic concept of all the electric components, the storages, all of this has been done by ourselves. We decided also quite early on that we want to do the planning using BIM technology, BIM meaning Building Information Modeling. So that now we have a digital twin of the building, where all the sensors and all the features of the building are implemented in a digital model. That was very useful during the planning in order to also communicate with all the partners. We had the shared cloud platform where these building models has been hosted, and our planning partners all could access the same data for the detailed design of their respective parts. The planning partners included architects. We had a BIM specialist that coordinated all this cloud storage that I just spoke about, and made sure that all these different partners could access the data they needed. And of course, we had building service engineering specialists all doing their part of the planning. And from the get-go, this building was planned as a pilot building. So we really wanted to have a building that could show off the capabilities and the possibilities of renewable energy technologies. That's the reason that we have 4 different PV systems in the building. You would not normally do this, yeah, for sake of efficiency. You would choose only one kind of PV system and go with it for the whole building. But on each of the roof planes, we have a different way of doing PV. We also have the building integrated PV, as I said. We have different storage technologies. We have different charging technologies. And this has been done on purpose of having a showcase, a pilot for all kinds of renewable energy technologies. And yeah, even beside the CSSC project, we plan on go on with being a demo site and a building that can be visited, and others can go and come and see and learn from our experiences. That is really was a part of the planning process from the beginning. So now I want to show you a short video about the construction. It's a time-lapse video that gives you a little bit of a sense of the construction process. As I said, we started in November 2019, and all this footage is taken in 2020. So we had during the construction, we had no major problems. It went more or less smoothly, even in the Corona pandemic. It took quite a bit longer than planned because, as you can imagine, there have been time periods where construction could not continue due to some pandemic measures, and people needed to stay at home. But overall, I'd say for the construction, we did really not have any big problems, despite the technologies that we used being not really not just the standard. As you can see here, for example, on the right side of this roof, half of the roof already has the PV panels there, and you see on the left of the roof there are panels missing. That's because they all needed to be cut to size, and we ordered all these missing pieces here. These are tailor-made PV panels that we ordered really to size exactly of these cutouts, and they took some time to be delivered, but in the end everything was in place more or less in time, and really the construction process was quite smoothly, I have to say. Also thanks, of course, to my colleagues who spent a lot of time on site. The whole site management was done by colleagues of mine in-house, and yeah, so he might have a different tale to tell about how many problems we have, but I think overall it was executed quite nicely. So this was now the end of the construction process. That's what the building looked like at this stage. This was at the end of 2020, at the beginning of 2021. So the building was ready to be moved in. So here are some pictures of the construction process. You see different ways of the installation of the PV on the roof. On the video before, we did see that the PV panels have been also the roof elements, and here we on the left side of the building.
Na, ich bin jetzt dran. Jetzt habe ich.
On the left side of the building, we have a standard roof construction with the panels just installed above the roof without any structural function. And as I mentioned, the whole core, the whole concrete was also is also activated. This is the floor heating, but we also have
Sorry, I can't hear anything.
Yes, some problem.
I think muted.
Can you hear me again?
Yes.
Yes, we can hear you.
Now, yes.
Did you hear nothing until now?
No, we heard just from this slide you
Okay.
somehow muted yourself. Yeah.
Okay,
Yeah.
I was worried that my whole speech was
No,
not.
no.
Okay, now so good, you can hear me again. So as I said, this is now pictures of components during the construction process. You see here the thermal storages. You see the pipes for the building core activation. On the left side, you see on the bottom pictures, on the left is the preparation of the charging infrastructure. In the middle and the bottom row is the storage room in preparation for the battery storages. And on the right side here on the bottom row, these are the heat pumps. It's air heat pumps on the roof of the building.
Michael, I think again you somehow
Somehow when I change the slide, it switches off my microphone. It's strange. I never had this before. Okay, now I need to be careful. So on this picture, you see a part of the sensors. In the left picture on the roof of the main hall of the building, you see some movement sensors, temperature sensors, also of course the obligatory fire sensors. And on the right side, yeah, the cabinets with all the data servers for the building management and the load and flexibility management system. Okay, what actually what are the components that are part of the CSSC lab project? And they are the lithium-ion battery, the saltwater battery, thermal storages, the building core activation with the heat exchanger system, the charging system, equipment for mobile storage, the monitoring, and the load and flexibility management system. So here you see finalized the hot and cold storage. The left one, the white, is the hot storage, and the black one is the cold storage. We have about 1,500 liter water, so it's a water storage, and they are used mainly for the building core activation. So in winter we pump the hot water into the building, and in summer the cold water, which actually I have to say it works really, really well in summer. If you think back on the pictures of the building, you remember we have a big glass facade. So me and my colleagues have been a little bit worried before we moved in that it might get really hot in summer. But due to this building core activation with the walls and the roof being cooled permanently, the climate in the building in summer is very, very nice. It doesn't feel like it is cooled like in an air condition. It just feels like it has a nice ambient temperature, and you don't get the feeling of like cold air flowing around. So it works really well. This is the lithium-ion battery. There's nothing too special about it. It has about 32 kilowatt hours and is connected to the PV system and supplies the building with power when it's full and the PV does not produce sufficient electric power. Then we have the saltwater battery. It's in the same room on the other side. It has the same function, but it uses a different technology. So the electrolyte here is salt water, which has the big advantage that it is not inflammable. So these saltwater batteries are quite a bit safer than the standard lithium-ion batteries. But of course, you can immediately see, I go back, they have the same capacity. This one even a little bit more. This is 32.6 kilowatt hours. This one has 30 kilowatt hours, but you can see the size is significantly bigger with the saltwater battery because the energy density in saltwater batteries is quite a bit lower than in lithium-ion batteries. So these are some advantages and disadvantages. And again, we really specifically chose two different technologies in order to be able to show them, present them, talk about what is good, what is bad, which are the use cases at which these technologies excel at. Then we have the charging equipment. We have several charge points on the parking spot. Here you see one of them with it's a standard AC 22 kW type 2 charger. We also have a DC charger right beside to it and several other charging points around the parking lot. And they are utilized already quite a bit. So I noticed that when we have an event, I would say about 15% of the cars usually are electric cars, which is a bigger share than in Austria in general. But of course, people visiting a building like ours, events about energy transition, about renewable energy, they tend to have more electric vehicles than the general public. So that the infrastructure is already utilized quite a lot. Then we have the building core activation. This is the main pipework of it. In the background, you see parts of the heat exchanger system. And of course, the building core activation is throughout the whole building, but here is the main pipework for the different cooling and heating circuits throughout the building. And then in the end, we also have this monitoring system and load management system. As I said before, we have a lot of sensors in all rooms of the building. And then on the right, you see our server station now in its finished state. We have a building management software running there on the servers where all the data is collected and all the control of the building is done depending on the sensor input. For example, if a room is not utilized, the proximity and presence sensors will notice that there is nobody there, and the heating for this room in winter, for example, will be automatically turned lower in order to not waste any energy. That's one of the functions of this system. So what kind of activities did we already do, and or what have we planned for the future? Since the opening ceremony in October last year, our demo center is open to all visitors during the business hours. So there is no need to make an appointment if you just want to come by and have a look. One of our tenants is a coffee shop, so that's also open during the business hours. And we also offer guided tours, but of course they need to be booked in advance. You can do this on the homepage of the building at Solar One, and can book guided tours. And we already have questions from, for example, schools or universities that would like to come and visit and get an excursion and talk about renewable energies. We already also held the first open days on the 16th and 17th of October. There were in total about more than 200 participants around the region, private persons, representatives of municipalities. Was quite a successful event. Also, within the CSSC Lab project, we had our first demo session and workshop that was held on the 5th of November with stakeholders from municipalities, communal services, and companies. And also in the first half of 2022, we plan to make the next demo session. And one of the things that we plan for the future is to have a regional energy congress that we would like to develop into a week-long event, but we plan to start either in this autumn. Depending on the pandemic situation, we might postpone it to 2023 because we really want to have an on-site event where lots of visitors can come, where we have keynote speakers and discussions going on. And we think if there are still pandemic restrictions, it would be not really what we want to do. So we might postpone this to 2023. But the plan is to have each year in autumn an energy congress, not only about the Solar One, but about all the activities that we are doing in our region. So this was an overview on the Solar One demo center in Stegersbach. I hope I could give you a bit of an insight into our part of the project. Any questions are welcome, maybe in the break. And with that, I will give over to the next demo center. Thank you.
Thank you very much, Michael, for the very detailed presentation. It was very interesting, and I'm sure that many people will plan for the future visit to you. So now I invite our partners from Bulgaria to take the floor and to present us their investment, please.
Hello, everybody. And just to put my presentation online. I don't know, but it's given. It's not possible to put on the Teams.
Just a second to check if everything is. Okay, can you do it now?
Not again.
Can we maybe then go with the next session, and maybe you can try to send me the presentation, and I will share it on my screen.
Okay,
Yeah.
I'll send you immediately.
Yeah.
Okay, then Roman, investment in Destinec, can you take the floor and start the presentation?
Yes, thank you,
Okay,
Cosmin.
thank you.
Okay, hopefully you can hear me well. Well, welcome to our midterm conference also from my side. Let me just share my screen, my presentation. Okay, hopefully you can see it.
Yep.
Yes, it's okay.
Okay. So today I will, in behalf of the project partner municipality of Destinec, present the demo investment at the location of Destinec. First, just a couple of words about the municipality. Destinec is a small rural municipality in the northeast of Slovenia, in the Podravia region. The population of the municipality is only about 2,600 people. The center of the municipality is a small settlement where the main public buildings are located. The municipal office, the postal office, the police station, the primary school, and the demo investment building, which is the kindergarten in Destinec. On the left picture, the photo, you can see it's marked with a red circle. So why I'm showing you all this is just as a information. Such layouts of municipal centers are characteristics of most of the smaller municipalities in Slovenia, towns where the public buildings are more or less the neighboring buildings. So many municipalities in our country are suitable for such projects in the area of sector coupling, energy storage, energy communities, microgrids. Well, in short, any energy projects involving one or several public buildings. Therefore, such innovative projects have or will have a high replication potential in the future. Here is just another photo of Destinec, where you can see that green is dominating in the small municipal centers in our country. But let's move on to our demo center. As said, the demo center is located in the kindergarten Destinec building, and it's focusing on demonstrating a system of photovoltaics combined with a stationary battery as an alternative to the existing net metering system and electric vehicle charging station. The investment includes all the equipment for controlling and managing the electric loads from the grid, the PV system, and the batteries, to be reproduced by a programmable electronic load under a demand-side management system. Involved partner in the implementation of the demo investment are, of course, municipality of Destinec, and we, the local energy agency of Spodnja Podravja, as a technical support for the municipality, and of course here's also Complus Ultra as a demo investment coordinating partner, and well, not to forget the project lead partner who was always available for advice and support if needed. And the main stakeholders, main actors involved in this process is the contractor who supplied and installed the equipment of the demo investment, which is the battery system. They also installed the charging station and of course all the equipment that's needed for the operation and controlling of the center. Then there are two more companies. One is Energia Plus, which will install the PV plant, and the electricity distribution company Elektro Maribor, who was responsible for the connection to of everything to the grid. So the concept of the demo center in Dessenink is quite simple. Battery system together with a solar power plant that serves for self-supply of the demo building. From the moment the center will operate fully, it will be operating in the most optimal way. That means at a cost optimum, and which means that it will first use the electricity produced by photovoltaics, then the energy from the battery, and if this is not sufficient, it will use power from the grid. On the other side, the excess production from the PV system will be stored in the first place in the battery, in the stationary batteries, and then in the car batteries, and at last in the network as a part of the electricity self-supply scheme. Here at this photo you can see that the demo center and the installed equipment is not limited only to this one single building. It's covering the surrounding area. The PV installation will be installed on the roof of the neighboring building due to the more favorable roof position and shape. The charging station is not located directly at the building, but on the nearby parking lot, which makes it more accessible for a wider public use, and therefore makes much more sense. In regard to the planning and construction process, municipality of Dessenink and we, the local energy agency of Spodnja Podravja, with the support of CPU, started with the preparation of the initial concept already at the CSSC lab application stage. As soon as the project started, the planning continued. Dessenink selected the initial building for the installation, and at the same time we worked on the final concept of the demo installation in order to specify the needed equipment and prepare the procurement, prepare for the procurement process. On February 4th of February in 2021, the public procurement was published. The deadline was till 15th of February, and after that, a contractor was selected and immediately started with the work on all needed plans. Well, due to the decisions taken by the municipal council in June, we had to make some changes of the project and had to select a new building for the demo installation. At this point, it was already clear that there will be delays, and at the end, the kindergarten building was selected for the installation, and the work could continue. The concept itself stays the same, and luckily there were no changes to the already selected equipment, and the works could start. In parallel, a permission for the connection of the battery system and later the PV installation was obtained, and the battery system was connected and put in operation. The installation of photovoltaic will be hopefully done in the coming weeks, so that we can finalize this as provided with our adjusted timeline. So during the planning and the construction process, we faced two difficulties or issues that have been resulted in these delays. The first was already explained with this replacement of the initially selected building, and the second one was with the permission of the battery system and PV installation. The application was submitted, but due to the current COVID situation, the waiting periods have greatly extended to up to 6 months. But thanks to a good communication, we managed to obtain the permission sooner as expected, and the process continued. In parallel to the process of obtaining this permission, the works have already started. The equipment was purchased and supplied to the location. All the wall breakthroughs, the excavations, and laying the cables have been done, and the equipment was installed. Here in the technical room, installed the battery. And 2 batteries. The solar edge inverters, the outside charging station with those 2 charging points. So here are some of the technical parameters. 2 batteries with a capacity of 20 kilowatt hours, the possibility of upgrade to up to 256 kilowatt hours. The system efficiency is more than 95%. And then the inverters, the charging station, and we are still waiting for the 24 kilowatt solar PV to be installed. In terms of financial parameters, the cost of the equipment and works that are part of the CSSC lab investment are about 40,000 euros. Here is a connection scheme, but I don't want to go into details here, and not to get the technical. At this moment, we're still facing some difficulties with the equipment and consequently with access to the web monitoring. But nevertheless, here's a screenshot from the web interface where you can see what parameters are being measured and displayed. At the screenshot, you can see that the production from PV is it's 0 because it's not installed yet. So the batteries are being charged from the grid during the low tariff times, and further you can see the electricity from the battery that is being used at the building and the charging station. There are still some typos here to be corrected, but these are the monitored parameters. The plans for the coming months and short-term plans for the period until the end of this project are to finalize this PV installation. And we are facing difficult times with COVID. Study visits will perhaps not be possible for all interested. We will prepare a virtual tour in a form of a video presentation of the demo center. So for all interested, this will be possible to see at the CSSC Lab online platform. And of course, we will carry out study visits to the demo center. If there will be a lot of interest, we will prepare open days where these visits will be possible. If interested for a live visit, please contact us. The contact will be at the end of my presentation, and the demo center will be also promoted on regional and national events. And well, that was a quick presentation of the demo center in Destering, and well, thank you for your attention.
Thank you, Roman. Thank you very much for your very helpful presentation. And I'm sure that in the future, many of municipalities will look to replicate solutions from you in similar projects. Thank you very much. We will try now again, Bulgaria. Todor?
Yes, I'm here.
Thank you very much. Please.
I can share the screen, or so Todor, you can just proceed, and I will change the slides. Yeah.
Okay. Thank you, Marco. Hello, everybody from Varna, Bulgaria. I will show our demo investment, and the goal of my presentation is to not just to show our WAP, but what is the reason and what we expect to have as added value after the end of the project, let's say. Next slide, please. We are located in Varna, Bulgaria. Varna is the third biggest city in Bulgaria. We are located on the Black Sea coast, and according to our opinion, we have really big potential, sun potential, and the PV potential of the integrated in the building photovoltaic is around 470 megawatt peak, or it can produce 600,000 megawatt hours per year. So as you can see, the goal is to be very well developed and distribute the PV production, energy production in Varna, because now the level of PV in our city is very, very low. The next slide, please, Marco. Here, another reason, maybe most of our east part of Europe countries now have this problem, is the very rapid increasing of electricity prices. On the graphic, you can see only for 1 year how much is increasing the prices in the electricity exchange in Bulgaria. And the electricity consumption in Varna, it's a little bit more 1 million megawatt per year. And home consumption, it's around 600. And if you remember the previous slides, we have potential, let's say, to cover the home electricity consumption via photovoltaics integrated in the buildings in Varna. The price of the electricity for homes, there is now moratorium of the price in Bulgaria, and it's fixed around 20 euro cents per kilowatt hour. But for the industrials, it's almost triple. So the expectation, our expectation, and the expectation of the society is to increasing, which is another stimul to develop the PV electricity production. The next slide. The CC WAP and our pilot model, it's just on time, let's say. The goal is to make a positive energy building. Unfortunately, in Bulgaria, we still not have a net metering, and it's a little bit hard to be a prosumer in Bulgaria, but as we know, the EU directive obligatory to change our law, and our expectation is during this year to the parliament to make the necessary changes and to be possible to be prosumer in Bulgaria also, which is another positive for positive energy building. The pilot model was ready in the beginning of the previous year, so we have a database for 1 year. And it's working till January 2021. The next slide. The concept. Our goal is to prove the model suitable for our city, which have to cover all necessary energy needs during the whole year. So we combine photovoltaic with battery system to cover the electricity needs. For the domestic hot water, we use again photovoltaic, but through special controllers which convert the electricity suitable for the boiler, which reduce the price, investment price, to make this system a normal boiler with photovoltaic. Also, we use pellet boiler and gas boiler for heating purpose, because during the winter the sun potential is low if you compare with summer. And we have to cover the heating needs through pellet or gas boiler. Why there is two boilers? The reason is the price. Now, the last month, the government increased the price with 30%. Next month, they say it will be reduced with around 15%. The pellet situation is also quite same. The price is very fluctuating, let's say. So the goal to have two boilers is to choose the cheapest way to cover the heating needs. And the goal of the concept of our pilot model is to propose to the stakeholders, let's say engineers, investors, municipalities. The example how to cover your all energy needs through efficient way, not only technically but also economically efficient. And if you're interested, the payback period is around 5 to 7 years. Of course, depends on the price of the all energy which we deliver. But increasing prices give us hopes that it will be decrease the payback period. The next slide, please. Here I show you how it's work our system. It's also showed on the website, and we have a photovoltaic, we have controllers, inverters, of course, and batteries. Here is electrical system, and we have PV models through controller which deliver the electricity to the domestic hot water boiler. And the main challenge is this: how to combine all this equipment through efficient way, and to be, let's say, the cheapest investment. So we have to cover our energy needs, but to be with more efficient on the investment point. Of course, the main advantages of the concept is energy dependence, which is definitely a topic now in our country. The next slide, please. Here I show you the planning and construction process. The project idea was 2019. We developed a concept and implementing the necessary project design activities. We make public procurement in December 2020, and in January the system start to working. The funding is from the project and also private sources. Actually, the building is office, small office building with place for presentation also, and it's like a small model how to make energy positive building. It was very interesting for Technical University in Varna, and we make some trainings for the students from the Technical University. The next slide, please. Here I show you the technical specification and pictures from the equipment. We have almost 20 kilowatt peak PV models, 3 solar controllers. Here maybe it's interesting to say the PV models the position of the PV models is oriented on east and west. It's not on the south, where is the somehow the reason is because we need more electricity during the morning and in the end of the day, when is most consumption of the electricity. That's why we oriented the PV panels on east to west, which is actually a very good approach to cover the electricity needs. And that's why there is 3 solar charge controller because most of the electricity consumption is during the end of the day. So we have two controllers on which manage the PV panels from the west and one from the east. We have 30 kilowatt hours battery, and you can see the power of the pellet and CNG boilers. The next slide, please. Here I just show how many parameters we monitoring. We have full database for 1 year, and now we make validation of the data just to be sure everything is correct. The next slide, please. The goal is to have full data of these parameters to be to help to the engineers to develop a good project design for this kind of buildings or other type of buildings, and to have more information, which we hope to give a good start for the implementation of PV panels integrated in the buildings. Here I show you volt ampere characteristics. I choose 1st of August in 2021, which is as you can imagine, a very sunny day, and we see how the consumption is changed, and most of the consumption, as I say already, is afternoon. The next slide, please. Here is a volt ampere characteristic of the battery system. Again, 1st of August. In the beginning, you can see we discharge the battery system because it's during the night, and for 3 hours the battery is charged, full charge, and after that the all electricity consumption is covered from the PV system, and when in the end of the day, again the battery system give the electricity to the office building. The next slide. And here it's again battery system, but according to the level of the charging in the percent, again 1st of August, and here we can see quite the same. And our we produce too much electricity according to electricity needs during the summer period. The reason to have this capacities, of course, winter season, to cover the needs during the winter season, which give us, let's say, idea to use this electricity during the summer for the charging electricity cars. And this year, 2021, we our partner install one more inverters, which will be enough for the charging station, and of course for this building maybe half of the cars are electrical cars, which is the sector coupling between PV and electric car. The next slide, please. Here I'll show again discharge of the battery. Again, we can see it during the night time. The data is good for the estimation how big battery we need. And I just want to show you we have in this data. The next slide, please. The next slide is the charge period. If you look, the charge period is 3 hours. After that, the battery is full, and we cover our needs directly from the PV system. The next slide. And here is how much electricity we have from the 3 controllers. As I told, we have 2 controllers on the west side and 1 controller on the east side. 1 and 3 is on the west and 2 is on the east side. And the purpose is again to have a database. What exactly is the production if you oriented the PV panels on this side, because on the south there is plenty of information, but on the east and west it's not very well developed, this kind of database. And the good things here is again for the engineers, but also for investors, to have an idea what exactly they will produce if you oriented the photovoltaics on this site. The next slide, please. So we make virtual study with stakeholders and students. There is a big interest from the technical university, from the investors, and also from the municipality. We make some kind of webinars, but maybe after April 2021 because of COVID, of course. And also we try to arrange the meetings with potential investors because the interest now is on rise, and we hope to help them and to make the investment on the proper way. So that's all for me. If you have some question, I will answer. Thank you, Marco, for supporting.
Okay, thank you. Please.
Yeah, I just have one question on this. How much of the energy do you have to export, if you have to export to the grid? Or you completely store all of the electricity in the photovoltaics and in the batteries, and that's it. Do you have any excess of electricity which you produce? Do you have any problems with that?
The main goal was to be disconnected from the electrical grid, because it's more interesting for the people to show them it's possible to cover your electricity and energy needs without any connection with grid. It's just marketing approach. So we don't have connection with grids, and that's why we put this charging station to use the electricity during the summer period for the electric cars.
Okay, that was my question. Yeah, okay. Maybe we can also have some questions after we go through the last demo center. Then maybe for the all four, we can see if there are any questions. Just let me change now the presentation from just a second. Yeah, I think that it should be seen now. Yeah, okay. So I will give a brief input and an overview of the last demo session in the Zagreb County, which is prepared by our partner Zagreb County in this project and assisted by Regea. Just for the some geographical reference, Zagreb County is a regional public authority which surrounds the capital city in Croatia, the city of Zagreb, and it has around 317,000 inhabitants in 9 towns and 25 municipalities. There are several potential locations which can be used since the county is our partner, and there is definitely a potential for replication for actually the whole CSSC approach. Just to as a general approach to the demo center, we have started at the before in the process of application of our project, where we defined the models, selected pilot locations throughout several locations, selected the best one actually, which can fit our purpose, then created the whole demo center documentation and went to the public procurements. The installation of the equipment and the integration of the demo center was planned for the 2021, just as in other systems, but I will dig more into it, why we postpone it and why we are still in the process of installation. So for the start, description of the demo center was to create the technical possibility to be heat presumers. Just as you know, there is a possibility for photovoltaics to produce electricity and then maybe sell it to the system. We wanted to check if it is possible and how to integrate it in the heat generation system. So basically what it requires is integration of solar thermal collectors, which are installed usually on the rooftops, but now more and more on the green field due to their heaviness, and since they are quite heavier than photovoltaics. The next part is the smart substation, which enables the interaction of the system and the pilot building, just as you have the so-called DSOs for the electricity. In these terms, we have the district heating networks, which provides you with the heat. This smart substation should include monitoring and regulation systems, be very advanced, and provide us with the input of how much energy is produced and sent to the system, how much is stored in the heat storage, and so on. So that was the initial demo center and our idea, which was developed. The goal is, as I said, to achieve heat presumer in the district heating system within the Zagreb County, within one of their buildings, and actually to achieve lower levelized cost of heat for public buildings, and somehow, on the other hand, push and I would say trigger our very closed heating sector to start adjusting to all of the new EU directives and national laws and legislations for, I would say, liberalizing the energy market. As our example, we opted to have a demo center within the educational building, simply to utilize and make a synergy with educational part and try to share our specifics and knowledge from to students. And just to mention that the impact of the local society can be very high, since in the Zagreb County we have 3 target cities within which have the district heating system. So this model is very applicable and can actually provide not only for the public systems but also for households and other sectors a great way for decarbonization. The pilot project was selected to be a high school in the city of Zaprešić, which has available rooftop area around 4,000 square meters. You can see it in the right picture with the roof, and then the roof of the school, and then also of the gym. It has the biggest sport gym in the Zagreb county, and it is very much used, and it uses a lot of energy. And it is only high school in this part, which around 50,000 inhabitants, and it is in some terms one of the main locations in charge of these sports events. Current heating sector is located in the building on the left side, in one of these right doors above the car. And it contains individual natural gas boilers for space heating and electric boilers for hot water preparation. It is very close, as I will show later, to the main district heating system boiler room, and of course future solar thermal fields, which I will go on. So with that, we finished the first 2 steps, and we're ready to prepare a detailed documentation and everything that went on. So our functionality was based, as I said, on the smart heating substation, which would have solar thermals on the roof and provide the energy. First, it would go to the heat consumption, to all the needs on the building. If there is excess, it should go on the storage, and when the storage is full, or when there is no need for consumption, it should be sent to the district heating systems. Regarding the solar thermal collectors, we have scanned the EU market and found quite several, I would say, available solar thermals, and the specifics about it is that those are vacuum solar thermals that can produce temperature up to 90 degrees with top of the art, I would say, technology from one company in Switzerland. And based on their examples and their model of the district heating in Geneva, we have tried to replicate it and try to focus it in here. And you can see that the initially planned gross area of the panels was around 500 square meters, which would produce around 350,000 kilowatt hours per year, and would give a great natural gas savings and CO2 reductions, which is very actually relevant for the county, which expects new, I would say, price of the natural gas in this year. So due to the changes in the energy market, it was a great push for this. On the right hand side, I put some other information and just that you can see, while these pictures are from district heat Geneva, just to show you how it will look like and how the boiler room with all the heat exchangers should look like in our case. Regarding the boiler room specification in the school, which will consist of, as I said, water tank equipment, heat exchangers, and smart, I would say, equipment to monitor it. We opted out for these three heat exchangers, and our external service providers gave us the detailed schematics and everything that it is needed to control and interact between heat storage, solar thermals, consumption, and district heating systems. On the other hand, after we finalized it, we happily went to proceed with the public procurement and to make the whole, I would say, pilot ready. That was in 2000, and I would say that start of the last year. But we encountered with several issues since we went for the rooftop approach. The first one and the biggest one was the price of the gas, which was very uncompetitive, I would say, at that time, and it was completely out of a way of how to organize a district heating company and public building and all of the actors to go into this. And on the other hand, we had some problems with the rooftop integration, since those are very heavy, around 55 to 70 kilograms per square meter. So those are a very heavy load for roofs. And the system was too complex, not in the that it was not was able to be done, but the space in the boiler room was simply too small to integrate such a large investment, such a large equipment. So what we were then had to do is to stop everything and to collaborate with the city of Zaprešić and with the district heating system and Zagreb County to find the solution. And it can be seen in the picture. We basically, from the existing main boiler room, moved the solar thermal from the roof and moved it to the solar field, which was agreed with the city of Zaprešić to install the larger scale of these solar thermal systems. Since in this year and a half that we have negotiated with the district heating systems, they really made sure that this is feasible solution for them, so they opted out for the larger scale, and that actually forced us now to change the equipment and their structure, but most important is that it forced us to do a so-called virtual solar heating plant, which basically means that this share on the field will be dedicated to the demo center, and sensors will be there to monitor everything and to I would say let us know what would happen if this system was only for their purpose, to see the excess which is exported to the system, to see how much is used for their consumption and how much is in the heat storage. Just a few questions about the, just a few sentences about the large-scale solar field. So as I said, we moved it from the small scale to the large scale, and that was basically due to our one of the projects that we have done in under Horizon, which was called Keep Warm, and basically it focused on the district heating systems in several countries with all the partners in here, and it is very maybe relevant for this part of Danube region, since it provided not only for us the large-scale solar projects for targeted cities, we had produced several documents, but also for other installations such as heat storages, biomass, combined heat and power plants, and so on. So maybe if you will have time just to go in, if it will be interest of you. As I said, we had to change and delay, change the concept and delay everything. So we had to prepare the new documents, include several more stakeholders, which meant more paperwork, more documents, and then adjust the price of the heat, which was actually the hardest part to do. After that, we proceeded with a model with public procurements. As for new functionality, as I said, solar thermals were moved from the school to the district heating system, so they are directly connected to their network, and with the virtual monitoring, we will present parameters for the school. Regarding the boiler room in the school, simply we moved these two to the district heating systems from that schemes that I presented before, and those are moved to the boiler room and to the solar field, where everything else remained the same. What actually was relevant for the investments of the stakeholders is that we had to recalculate the whole perimeters, adjust the engineering studies and all the, I would say, aspects for the public procurement, but also to set on both sides a realistic price, since, for instance, now it is expected that natural gas will increase up to 50 to 60% in next few months, and it was very, I would say, dynamic environment. While on the other hand, we are dealing with the national district heating company, which is a part of the national energy company HEP in Croatia, and when you deal with such large systems, it takes time to prepare documentation, especially in terms of innovative solutions. From what they were used to do is to contract, have a public procurement for design documentation, and then to go and proceed with the building in a separate tender. For now, we have tried to simply introduce everything into one public procurement, and which was happily accepted. So now we were working on that. While on the other hand, as I showed in this picture, the solar field is now much far away from the main boiler room. So what they had to do is to build this pipeline in green, and this is around 400 meters. So they provided the 150 meters and still building the rest of the grid. On the other hand, there was a quite tricky situation in the getting the green field for the usage, but it went really well. And after several meetings, we even agreed to have a city of Zaprešić, as it is our associated strategic partner in the replication model, since they also have a large problem with their public buildings. On top of that, one of our target cities are also currently into negotiations to replicate it to one school, just waiting for this project to happen and to see the outcomes. As I said, the adjustments of the heat purchase agreement or the contract was the most challenging thing for us, because new calculations really forced us to adjust the whole calculations on one side for the district heating, but on the other side also for the public building. And on the time span of 25 years, district heating company can achieve up to 4 times lower levelized cost of heat for this large scale, and that will definitely reflect directly on the financial viability of the network. And taking into account the whole operation, maintenance, heat losses, and other technical aspects of in the district heating systems, levelized cost of heat will be sorry, I forgot to mention, 10% cheaper than it is expected to be in the next period with the gas, and it will be for 12 years, so fixed contract with a fixed price from this field. As for the virtual solar thermal plant, as I said, some sensors had to be moved, relocated, and so on. So first sensors will be installed in the solar field, simply to monitor the whole the parameters of the whole field, and it is expected to cover the 100% of the whole heat demand for district heating system. And in terms of our demo center, it will provide, I did not put here, around 80% of renewable energy to our center, while here are all the other informations. For that, it will use 30% area of the field to produce this amount, and that is the share actually that we want to see. Of course, as I said, the other part is to provide so-called virtual plant for smaller field, for the field that supposed to be installed on the roof, and with that we have a much larger information. It is around I think 45 no sorry, not 45, 35% of demand, and requires, I would say, much less money, but also impacts with smaller numbers. I just wanted to put in here information about our live data, which will be monitored. So we will present everything that is relevant for this smaller field on the online platform by following the same approach that we had in previous demo sites, to monitor how much of the energy is produced and consumed, to check the data on the heat storage in terms of temperature and the share of I would say level of fill, and in the end to provide some financial savings as our KPI. Lastly, I will say just several things about the current status. So everything that we mentioned here was prepared in the form of documentations, and now we are waiting for public procurements to finish, since it is not in our area. For the public procurement of the boiler room, we need to have the solar field in pipeline, I would say, and that is happening with this memorandum of understanding between included stakeholders. Meetings are constantly organized, and we are aiming to fully finish our demo center in next few months. That is all from my side. I don't know if there is any questions on this or on this concept or of the pilot. I'm happy to provide more information. Okay,
Seems like we have no more questions. So I want at final to thank you very much to Marco, but also to Todor. I don't do it before. I think all the projects have, and I'm confident about this, they have a high replication potential, and there are good examples in all the region and national, on the national level. So thank you very much, and please, Marco.
Yeah, thank you. I think that we can move forward with the next part, which is the showroom of good practice examples on these aspects. These are basically your input, your presentations that you agreed on with our project partners. So we can start with 15-minute slots on first four, I would say, and don't worry about the time. If you need more time, you can dig up more. And this is actually the part where we can see what other initiatives, what other projects are concerning on the CSSC aspect, and maybe collaborate with them. So with that, I would like to invite the first good practice. It's harmonizing energy and mobility planning. So if you could share your screen, I made sure that all of our attendees can share the screen, and I think that you should be able to do that.
I don't know the reason, but
Yeah, maybe you can again share it with me, and then I can.
I already sent you the presentation.
Yeah, and then we will wait for just a few minutes until it arrives, and share it on the.
It's simple.
Yes. I still haven't received it, but we will wait for just that. I would maybe just take advantage of this to say that maybe other partners which haven't sent us their parts of presentations, if they could send those presentations, just to make sure that maybe I can share those if you will have problems like Todo. Some of you already provided us, but please make sure that for this session we have all four of the presentations, and then the second one we will also try to do this in the same way. Tudor, have you maybe sent the presentation?
I already sent it.
Maybe we can go with the next one if it is. and then move back to you. Yeah, the next one is the renovation of hotel energy system by Albena.
It's again.
Yeah, then please send those.
I
Maybe.
sent you, but I don't know. Maybe
okay. No, but I only received without attachment, only the email. Yeah. Okay, maybe we can go with transforming a social building into a NZEP from our Romanian partners in Alba Iulia. So maybe we can go on that presentation by our partners and then go back to Bulgarian cases. I apologize for that. And yeah, I ask you just to share the presentation.
Okay, hello. I'm trying to share my screen now.
Yeah.
So you can see it, right?
Yes, excellent. Thank you.
Okay, so my name is Maria Elena Zeman. I'm working for Alba Iulia municipality. I'm public manager in the city, and I mainly work for attracting EU funding for the development of the city. So the city of Alba Iulia is the largest fortress in Romania. It might be the most interesting capital you have never heard of until now. And we thank you for allowing us to be part of this project as associate partner together with our local agency, ALEA. And what I'm going to present is something what during the time we managed to do to our city. Of course, we start to collaborate with experts who can bring added value to the development of the city. This is how we started also the collaboration with ALEA, but also with international experts like Jan Gehl. Jan Gehl is one of the architects in the world who managed to close the Times Square in New York for cars. And he came in Alba Iulia and help us prepare a study for our city, how to make a city for people. So, of course, one of the favorites words said by Jan Gehl is that a good city is like a good party. People stay longer than it's really necessary because they feel good. So this is what we want also for our city. And because everything starts with the planning and strategies, of course, the commitment of the city is very important when we want to reach the goals. By adhering the Covenant of Mayors for Climate and Energy with the help of ALEA, we committed to reduce the CO2 emissions with 40% by 2030. Of course, it's very important the collaboration with ALEA and also the Energetical Observatory Energo, because the data collected is actually the data who help us make the diagnosis of the city and to very realistic establish the goals to reach. So in this respect, we have this very important. Also, starting with this year, we had the commitment to the Green City Accord, also another initiative of the European Commission. Together with other 4 cities in Romania, we are there to commit ourselves to have a greener city by 2030. And we are the first city in Transylvania to receive the European Energy Award from His Excellency, the Ambassador of Swiss country. In August 2021, we became the first municipality to receive the Sustainable Community European Energy Award, and the performance evaluation was made on the basis of 79 indicators and 6 areas of energy efficiency. We are also happy that we managed to respect the deadline in submission of the expression of interest to become one of the 100 cities selected by the European Commission to become climate neutral and smart city by 2030. Here also the collaboration with the local partners, stakeholders, the local agency for energy, ALEA, but also other energetic managers of the city, we managed to submit the application on time. So fingers crossed, Alba Iulia. Of course, when we establish our goals, we take into consideration what already Alba Iulia did in terms of green development, sustainable development. So we have the fantastic Mamut bike lane, 5.5 kilometers long, and the Arboretum Park, Dr. Ioan Vlad, to 21 hectares with 1,100 species. And we want to develop as well our infrastructures for bike, for sustainable mobility, because as other cities have to do, we also have the urban mobility, the sustainable urban mobility plan adopted in the city. Part of the urban mobility projects, I will briefly go through them. We have 300 electric bikes that will come into the city and will go into this local transportation system for the public operated transport, 13 electric buses, 4 quick charging stations, 18 kilometers of road rehabilitated, of 95 cameras for video surveillance, 45 motorized bus station, and 1 management traffic for the mobility. During the times, we managed to be involved in several projects with different programs directly financed by the European Commission, but also through the conventional regional operational programs in Romania. Here you can see just the part of the initiatives that Alba Iulia is currently implementing. Most of them are also related to energy efficiency. For example, 5G Victory, financed to Horizon 2020. It's a project through which we managed to install in 3 public buildings energy metering systems for 1 museum, the city hall, and the 1 high school. It helps us, and it helps also our energetic manager of the city to monitor well the consumption and the emissions in the city for these 3 buildings. And now I reach the case study that I will present, which is written in the agenda, is one of the most recently approved projects of the city, a project with a social and energetic dimension. It's financed through Innovation Norway program, and the implementation will go until 2023, and it's the elderly home for people in Alba Iulia, for 100 people living there. It's a social service of Alba Iulia municipality, and actually is the 2nd largest energy consumer in the city. As you can see in the pictures, the building already has renewable energy systems. So we have solar panels, which are on the roof and assures a good part of the energy in the building. However, due to law restrictions, now it's a little bit different, but until last year, Alba Iulia, as well as other cities in Romania, could not benefit of the entire renewable energy produced in the building with own renewable resources, because the energy produced, which was not consumed that time, had to be injected in the network, and the compensation was not made for the exact amount of energy produced. So it was not efficient for Alba Iulia, but also for other cities in Romania. But the good news is that starting with this year, we have the legislation for our side, and we wait for the operational measures to be implemented, but we will be able to compensate the energy produced with the energy that we consume. So what you can see here is the building. The budget established for our project, it's 1,209,004 euros, and the grant is 1,100,000 euros. And the grant intensity is 85%. Among the objectives, so through the energy efficiency measures, I have to say, sorry for not mentioning earlier, that the project was submitted during the CSSC lab project, and it was inspired by the solutions that we find out through the meetings that we had with our local energy Alea company. So through this project, we are going to reduce the CO2 emission in the building with 47%. We are going to increase the energy production from renewable energy sources. Beside the solar panels that we already have, we will going to have heat pumps that will generate geothermal energy. We will also have the reduction of annual savings of 11%. That means the equivalent of 29,000 euros reduction. Also, because it will be a new and innovative system that was never implemented so far or tested so far in the municipality, we will also have the training for the operating personnel with the local energy Alea, but also with other partners in the project. In 2024, we will have the first day to start testing the new equipment. So this is the current situation that we have now. And the technical solution will include also the heat pumps, as I was telling you about. 3 groundwater heat pumps with a useful power of 130 kilowatt, a buffer tank, a hot water boiler, expansion vessels, circulation pumps according to the specifications given in the project. In addition to that, because I was mentioning that it is very important to collaborate with experts with expertise in the field, is that this project goes along with other initiatives that Alba Iulia already has in planning, submitted for evaluation or in implementation. One of them is the innovative energy efficiency solution for the Olympic swimming pool of Alba Iulia. This is the largest energy consumer in the city. Also financed through Innovation Norway and also proposing an innovative solution. And another project which is under evaluation, and it also has the energy storage equipment reviewed in the investment, is the energy efficiency solution through renewable sources for 6 public buildings of Alba Iulia municipality. Is the City Hall, which is also top 3 largest energy consumers of the public buildings, and 5 schools in the city. The other projects mentioned there, if you need additional information, I can send you after the presentation, but I remain together with my colleagues at your disposal. Thank you very much.
Thank you, Maria, for this presentation. As you said, if there is any questions, you can maybe ask now or later before the lunch break after we go through all 4 presentations.
Thank you.
If there are no questions, we can move forward with the next presentations or come back to the presentations of Todor from Bulgaria. I think that this one is okay. Simpler.
Yeah. Okay. The project which I want to show you, it's called a Simple or Sustainable Integrated Multi-Sector Planning. It was implemented by Dobrich Local Energy Management Agency and with the participation of UPSO also. The next slide, please. The goal is to combine SECAP and SUMPS, Sustainable Energy and Climate Action Plans, and Sustainable Urban Mobility Plans. We see these two types of plans are, the main goal is to reduce the CO2 emission, energy consumption, and to be more efficient and to use more renewable energy sources. But this is two plans which can work together, and if we try to connect these two plans, we will receive more better results. And that's the mission and the goal of this project, which already is finished. But there is a lot of materials and good examples which I think it can be useful for other municipalities. The next slide, please. So we know what is the SECAP. It's according to the Covenant of Mayors. The goal now is 40% to 2030. It's connected with buildings, street whitenings, public sector. It's connected with also small industries, which usually acting in the city. So the SECAP's goals is to manage energy consumption and energy efficiency of the city, all city players. The next slide. Okay, the next slide also. And Sustainable Urban Mobility Plan. It's according to the big cities, maybe more than 50,000 inhabitants. It's a very important, as Maria from Alba Julia says, the city have to be like a party and to want to live, to stay there more. And one of the reason and to be city friend, to be user friendly, the environment of the city is urban mobility. We know that the cars, especially in our city, is a big problem, and we have to propose to the citizens ecological friendly way to move in the city. So it's connected with SECAP. Of course, the SUMS is concentrated to bikes, to buses, to electric buses, and to reduce the need of the own car to use in the inside of the city. And in the project database, we can find a lot of examples how to combine SECAP and SUMPS. The next slide, please. And here you can see the website of the simple. So the main goals of the project is to collect these good examples, approach, and guidelines, and to be useful for project ideas of many of the cities, and to implement this project, and to find, of course, some financial possibilities. The next slide, it shows guidelines, training, coaching, and plans. Maybe it's good to give some examples. It's, for example, connection between electric cars and grids, and we can use the electric cars as batteries for the buildings or for the grids, and there is a lot of possibilities: vehicle to grids, vehicle to buildings, vehicle to, let's say, mini vehicle like scooters or small motors. And this is a lot of project ideas how to find a solution about, let's say, unstable renewable energy sources production, which definitely have to be covered through batteries. Of course, we have many possibilities to storage the electricity, and one of this is electric cars or big electric buses. So the idea of this example is just to stress your attention to this project, and if you try to catch some ideas, you can visit the website of the project. In the next slide, it show just information how many sources there is in the project, and of course it's free of use for you because it's a European project. So thank you for attention for this, and maybe to jump to the next presentation, which I will show the example of sector coupling and storage in one of the biggest summer resorts nearby to Varna. It's called Albena. Albena have...
sorry to interrupt. I think just that someone raised a hand.
Okay.
Yeah, so if there was any questions, yeah.
If you have questions, yeah, of course.
Okay. Hello.
Hello, foreign
colleague. Yes, I want only to add something very relevant linked to this strong European project, Simpla. We was also partnering in this project. I remember this project sustained a strong push from European level for integrating, harmonizing the main strategies from city level. In this case, mobility with sustainable energy. For this, I remember 2 years ago, we finalized to harmonize in several cities from our country, starting with Alba Iulia also, Sebeș, Oradea, Baia Mare, and Târgu Mureș. And I remember how strong activity we need to do, because generally, usually this plan are developed before separately. So to analyze together, starting from vision, starting from collection of data, proposing common methods, also to action with relevant effect in the two sectors, and finalizing with monitoring. I hope for the future will be developed more and more, and also a good idea to integrate also these two sectors, mobility, energy, into general planning at city level. It is a strong idea, Marco, you know, and probably in the next year we could have this kind of project for the first cities from our region, starting with a high implementation of their strategic planning. Thank you.
Thank you, Florian.
Yeah, thank you, Florian, for the great overview and input. I completely agree, and that is maybe one of the measures for our regional action planning, which can be then communicated in our partner regions. So that is definitely one of good outcomes of these showcases. I think that the next one is as you said, Albena. So here is the presentation. Yeah.
Yes, the Albena, as I thought, it's a really nice summer resort. And if you move on the next slide, please. It's one of the hotel there. Where is the example which I want to share with you? As you can see, it's a quite big hotel, and the goal here is to combine photovoltaic solar collectors for hot water, batteries, and most important, energy management system. The next slide, please. It's again pilot model. It was built, I think, 4 years ago. The project was under Horizon 2020, and the goal of this pilot model was to show and to demonstrate the benefit from centralized energy storage and controllable loads, which means, let's say, big battery in the first idea was to be in the substation, but actually it's moved and it was put in this big hotel as one of the biggest consumer in the summer resort. And the idea is to use these batteries as a buffer according to the prices from the electricity exchange, which have different prices every hour. So if you have a good management system, you can, as an investor, to reach really good results. The capacity is 200 kilowatt hours, and another buffer, let's say, is hot water. As a summer resort hotel, there is a lot of needs of so-called domestic hot water, and we integrated the energy management system not only with battery but also with boilers. And in case of cheap electricity, which is normally during the night when there is, of course, no sun, we use this cheap electricity also to heat the boilers for domestic hot water. Also, there was installed a PV system, 27 kilowatt peak power, which is installed, of course, on the roof of the hotel. And actually all electricity which was produced from this PV generator, it's all used inside of the hotel. The next slide, please. Here I show you what exactly we have. We have battery system, 3 models of battery system. Each of one is 67 kilowatt hours capacity. It's Samsung, and we have 3 inverters, of course. And as I already told, PV system. And here we can see 2 controlled volts. It's exactly for this purpose, which to manage the consumption depending of the prices which change it every hour, because during the project implementation it was not so interesting if on economical point of view, but now it's absolutely interesting because the price of electricity exchange now it can be from, let's say, 150 euro to 400 euro per megawatt hour during the one day, let's say, during the 24 hours. So the differences is almost 3 times. And with this management system and big volt battery system, we can manage our expenses for the electricity, which is of course very important for the hotels, through a very efficient way. And of course, with the help of photovoltaic system, we added to the efficiency of the electricity consumption. Also, the interesting point is combination with hot water or solar connectors for hot water. It's a very complicated system because it's necessary also to keep the batteries and to manage the consumers. So according to the management system, they move some of the consumption depending of the volts, electricity prices, and needs for the hotels, which introduce a really complicated management system, which is depends not only from the electricity prices and from the energy, but also from the needs of the hotel, because also it's important for the guests to feel comfortable. The next slide, please. Also, it's a pilot model which can be replicated in other hotels, of course, especially in our region. We have maybe more than 1,000 hotels, and actually it's starting some kind of replication processes, and the system is replicated, I think, in 2 hotels in Albena and 1 in Golden Sands, which is nearby to Albena. And we expect, according to the increasing of the energy prices, to be more and more interesting for the investors. Of course, it's a very important reduction of the CO2 emissions, which Also, it's attractable for the touristic, and it's some kind of marketing tools to attract our sea coast for the touristic. The next slide, please. So results I mentioned a little bit, but the most interesting results was about management system, SCADA management system, and to integrate it in the daily workable of the hotel, and to integrate it in energy efficiency and economical prices of the electricity. Also integration with domestic hot water boilers, and of course PV system, which make because there is a benchmark with other hotels, and make around 40% more efficient the electricity and energy consumption with other hotels on this type. And the next slide, please, which is I think the last one. Now the hotel is very attractable, and it's a point of interest of the not only hotel owners but also from other stakeholders like energy agency, engineers again, and other kind of industries, which for example this big food stores, they also start to put photovoltaics combined with batteries, and to be more and more independent from the fluctuation from the electricity prices, and they try to prepare for the, let's say, new situation for, especially for us, which because maybe 2 years ago it was quite predictable what will be the energy expenses, electricity expenses, and it was not every hour changing prices, but maybe it's changed one per year. So it's a, I think, good example, and if we made some project meeting here in Varna, we can show you. And the last slide, I think it's not necessary, but there is also a movie, very short movie, what exactly they implement. If Marco say it's okay, we can see it. It's around 4 minutes.
Definitely, yeah, definitely, no problem. Just to open it. Yeah.
It's not very long, 4 minutes.
I think that you will be able to hear it. Should I start it from the beginning? Yeah.
On the beginning. It's name of the project. It's Invade.
Yeah, excellent. Just I think that you will all could hear it. Yeah.
There is also subtitles, so it's not a problem.
Yeah. Do you hear it? When I
think it's not a problem about hearing, because there is a subtitles, and
yeah,
it's
okay, yeah, no problem.
That's all.
Yeah, I will maybe share the link in the chat just to have it all. Yeah. Maybe for the later if someone will try to watch it with yeah, sorry, I think that it should be. Yeah. Yeah. Oh, it's a little big, but yeah. Okay. That is I think the end of your presentation. So if there is any questions,
thank you for attention. Yeah. And thank you, Marco, for supporting.
Yeah. No problem. If there are any questions from this side and maybe replication in this interesting model, I know that it is quite interesting for countries with a similar situation with a lot of hotels and resorts. So maybe just a good example of how to do it. Thank you, Todor. And as I said, if there are any questions from the audience,
I'm here. I will answer, of course.
If not, maybe we can then move forward to the last session. Thank you, Todor, which will be from our partners in Czech Republic, and it will be energy storage example from our partners' agenda. So please, Mate, if you can share the screen and start with the presentation. Yeah.
Good afternoon. Okay, I will try to share my screen. It looks like maybe I need some permissions or something because there are some technical troubles. I'm not sure.
Yeah, then I think that.
It's look like there are some technical issues.
Then just let me know. I will share the presentation with you because Jan sent me the presentation. Just a second. I think that it should be seen now on your screens. Just give me a second. Sorry for the waiting.
Of course. Just the Microsoft Teams just is saying me.
Yeah,
that
I don't know why. Yeah.
Okay.
I don't know why some participants have the problems, but some are not. But I will definitely try to look into it for our breakroom sessions. Yeah. So I think that now you can see it. So Mate, thank you, and the floor is yours.
Okay. Thank you very much for the floor. Good morning, ladies and gentlemen. It's a big pleasure for me to be here. My name is Matej Hrubý, and I'm closely cooperate with Mr. Jan Jareš from Agenda company. My presentation will be strictly just about energy, just not only about our example just of capacity storage, but I also just closely mention just the energy situation in the Czech Republic. And also at the beginning, I would like to thank you and other speakers for their interesting presentations. So let's move to my presentation. How you may see the headline, I will be talking about energy storage in Plana na Lužnici. But I would like to start with general situation in the Czech Republic. And if I mean general situation, I will be especially talking about situation in context of renewable energy resources. I'm not happy about this, but I have to be honest, and just Czechia is definitely not a front runner in development of renewable energy resources. And if I'm talking about renewable resources, I just especially mean solar and wind energy. In the context of solar energy, the installed capacity is just about 2.2 gigawatts, so it isn't so bad. But just there is problem, or just there are some issues, because just the massive expansion just occurred between just 2008 to 2011, and since then just the development of solar energy just is froze. But in context of some investment subsidies, there are prepared another investments to solar energy, just especially just we suppose it will be somewhere between 6 to 8 gigawatts, and it's expected by 2030. So, and if we take it into context that the loads of our electricity grid during summer is just somewhere between 6 or 7 gigawatts. So and just the capacity of total capacity of solar will be about 8 or maybe 10 gigawatts. So it will be pretty interesting. But situation with wind energy isn't so happy. The installed capacity is just only about 340 megawatts, and just no major development is accepted, and also just not occurred in the last several years. There is problem with strong opposition from local communities, and also just it takes approximately 10 years to obtain the building permission and other legal documentation. So there are also some bureaucratic problems. In the context of these two energy resources, just the total share on the electricity generation in the context of solar energy is about 3%, and just wind energy just produce more than 1% of total electricity in the Czech Republic. What is also important, and it's just really painful, is our legal framework, because still at the start of the 2022, the accumulation of energy through the batteries is not based in our legal framework. We hope, or we suppose, that there will be some changes maybe at the end of this year, but or maybe in the middle of next year. But still, what is important, the battery accumulation is not based in our legal framework. So, and in the light of this aspect which I mentioned, so it isn't surprising that just in Czech Republic, it's only 5 battery projects is operation, and I will be closely talking about one of these. So please, if may, we just change the slide. Yes, and I also like compare states of, if I may something compare, I'm pretty like about it. And just if we are international platform, I'm just prepare a picture of share renewable energy on total gross final energy consumption in 2020. I suppose there are some animations, so you may just make two clicks or something. So yeah, so what? Oh, and there are some problems with this red line should be higher. This red column just it represents just European average. So it was in 2020, it was about 22%, and just in the red frame you may see Czech Republic, just the share in the Czech Republic. It was just about 18%. So it's closely correlates. Just with this, how I mentioned that Czech Republic definitely is a front runner in the development. But from the other side, just our neighbor, our Slovakia, France, Germany. So the situation isn't so bad, and even worse is, for example, Poland, Netherlands, or Hungary. So it's probably all about just the general situation. And now let's move to our best example, which we prepared. So please, another picture. Yeah, I will be closely talking about battery storage in Plana. The location of this storage is in South Bohemian region. The battery storage was commissioned in 2019, and the life expectancy is about 10 years. So until 2029, but honestly, we supposed that the life expectancy will be longer than just only 10 years. If we are talking about this battery storage, the capacity is 4 megawatts. It's the sea storage system with some sea stars. The wall technology includes control system, Li-ion battery cells, etc., etc. But in the context of this presentation, these are just marginal aspects. What is important is that just investment reached approximately 4 million euros. So it definitely wasn't cheap, but I have to be honest, that the public contract was also co-financed by European Union. And the battery is used mainly for ancillary services. If I'm just talking about ancillary services, I mean especially automatic frequency restoration reserve. It means that this battery helped to our transmission system operator to stabilize electricity grid. We should continue to another slide. Yeah, there is map of Czech Republic. Somewhere in the middle, you may see capital city Prague, and the location of Plana nad Lužnicí is somewhere near city Tábor, just near the green line, which represented highway. The Plana nad Lužnicí is small city, I suppose, with 4,000 inhabitants. The owner of the battery storage project is Sea Energy company, and this company also just operates for gas engines, and just basically their core business is supplement electricity generation from the solar plant typically. Yeah, and we may go to do another picture. Yeah, there's a picture of this battery storage. What is very important is just only it's outside, and it is in just container. So the installation and just every stuff with this was quite easy. And just how I mentioned, just in the background of the picture, you may see just the chimneys from this gas engine, and just this battery storage is just in area of power plant. We may go to another picture. There are some technical details, more technical details. Just according to tender documentation, the battery storage has granted capacity 4 megawatts. I am mentioning it, and just usable capacity is 2.5 megawatt hour, and it's guaranteed for 10 years. But how I mentioned, just we suppose that the lifespan will be longer than 10 years. The technology supplier was Siemens company, and also what was very important, so it was the delivery was realized in free container. Actually, there was one advantage, that the lower construction was cheaper than just to build some new building, and the commissioning of the battery also just took only several days. So it was pretty easy. And also the bigger part of the project is just completely supply of battery storage, which is located in the outdoor environment. So the whole battery is quite durable, and just in the outdoor environment also just is battery cells, transformers, control systems, etc. Yeah, probably this is all from technical details. We may go to another slide, and there is a main use of this battery storage. How I mentioned before, the utilization of the battery is not primarily associated with the storage of energy from renewable energy resources. Just you may asking why. I have just prepared one example, or just the solution is pretty easy, and its cost it's so expensive. I just give you an example because just in these days, just the average household in Czech Republic just let's say pay for electricity are using this battery storage just only for saving electricity. So every kilowatt hour is probably about 30%. The price is about 30% higher than just from electricity grid. So the reason is just only money. So and in this context, the main function of the battery storage is to create power backup for the provision of support service. And yeah, it's just these ancillary services, because just it's not only just case of these battery storages, but also, how I mentioned, it's also case of these gas engines, and just they are just quite quick start, and just they are pretty good in just supplements of electricity just from solar, because typically their just generation is intermittent. But also there is just close connection to photovoltaic, because just in some cases the battery may be just ensure a reliable supply of electricity sources with the heating plant, and just include is how I mentioned 520 kilowatts photovoltaic, and it's just in local, it's just associated with local distribution system. And theoretically, but we still haven't a lot of evidences about it, and it's just quite extreme situation. So theoretically, the battery storage may ensure transition and operation of this local distribution system in Iceland mode. But it's a very extreme situation, and just it never happened, and we just don't have any evidences about just the results, or how long it's theoretically possible. And just I have another slide, and I suppose it's and it's my final slide, and just thank you. There is great potential for replication, because the Plana was the first large capacity battery in Czechia. Just only in the context of these ancillary services, there is capacity approximately for 50 megawatts. So let's say there's potential for another 10, 11, 12 of these batteries, but it's only in the context of ancillary services, and just in the development of renewable resources. We also suppose that the new battery will be installed also for just storing this renewable energy. So the potential is much higher than the 50 megawatts. And also, just I was thinking about just benefits from reducing greenhouse gas emission. I was just thinking if there are some benefits, but it's difficult to identify, because in these days these batteries are especially just used for these ancillary services, and just we may hardly to say that, for example, it's just okay if you just storage I don't know 1 megawatt of electricity, just you may save more emissions than it will be generated from coal power plants. It's in these days it's hardly to identify, but I suppose in next years the results will be obvious. It's all from my point of view. Thank you for your attention, and just don't be shy to ask any questions. But I just understand that maybe a lunch break is more important than a question. Thank you very much. It was a pleasure.
A second showroom of good practices and examples from the Danube region. And after that, we will dig up more into two separate sessions on regional action planning and on the technical and financial modules. As for the break room sessions, I have seen that most of you have gave us the input on which session you want to you want to attend, then when the times come, we will activate these break room sessions, and you will be immediately transferred there. In there are 3 short interactions with I would say managers of these sessions, shortly to in smaller groups discuss about potential and other questions. That's it from my side. The next on the agenda is the latent ice storage, and an example from the Caldoa by Mr. Roer. You could share your screen and start with the presentation.
All right, thank you very much. I hope you can see it already.
Yes.
Okay, so I will start right away. Hello together. My name is Alexander von Rohr from the company Caldoa, located in Friedrichshafen, next to the Lake of Constance in Friedrichshafen. What I'm talking today is about a system of a seasonal latent heat storage to supply a complete little village, for example, with cooling and heat energy. That's my point today. Okay. What are we doing? Just a few words about our own history. We started about 20 years ago to develop the seasonal latent heat storage. It's we call it ice storage, ice tank, because it's based on pure water. We just take water, take out the energy out of the system, out of the water tank, and transfer the water to ice, and are able to get a lot of energy. It's the phase change energy between 0 degree water and 0 degree ice. So this kind of energy is the main point for us to use this energy to supply houses or even little villages. Here you can see a little picture, and it shows how it works. Based in the earth and the ground is our tank. Instead of drilling, instead of using the heat of the ground, for example, it's comparable. We use a tank, a closed water system with a heat exchanger system inside of the tank. In the tank, we just have what I already said. We just have clear water, and take out with a heat pump system inside of a house the energy, the heat of the tank. When the heating system starts, for example, in September, October, the tank is about at 15 degree, not more, just around the temperature of the ground around. It's about 15, 16, 17, 18 degree. That's the temperature we start in the heating season. Why? The main point is not to lose any heat. The best way not to lose heat is to have the temperature of the medium inside of the tank around the temperature of the ground area around the tank. So the ground during the complete year is about average 10 degree, plus minus 10 degree. And the water starts with about 15, 16, 17 degree. It goes down to 0 degree. So we are always around the average ground temperature. And that's the point, not to lose energy. During the winter time, the heat pump takes out the energy, the heat of the tank system. So the temperature lowers from beginning 15 degree to 0 degree. At 0 degree, the water starts to change to ice, And that's the point we are waiting for, because a huge amount of energy gets free during phase change from water to ice. We use this energy during the complete winter time to supply the heat pump system, to supply the complete house, the building, or even a village with the energy needed, with the heat energy. As long as we take out energy, as long as we take out heat, it means to cool down the system, but only till 0 degree ice, not lower. What we do is we leave ice behind. So we change the phase, use the energy, and we leave, after the heating season, we leave pure ice. It's about the size of the tank. We're talking about tanks from 100 cubic meters, so it's 100,000 liters, the smaller tanks, up to 2,000 cubic meters. So it means 2 million liters or 200 tons of water, ice. So that's about the size of our tanks we have. For example, change the picture now. After the heating season, we get the next summertime. And during the next summertime, we usually have to cool the buildings because of the sun. The heating, the buildings heat up, and we have to take out the energy. Usually we have to use a machine, a heat pump or whatever, to cool the system. What we can do is we take the ice we built during the winter time, and we didn't have to use energy to build the ice. The ice is a product from the heating, so we didn't need to use energy for that. So the ice is a kind of a waste product after the winter time. After the winter time is over, we left the ice behind. During the summertime, we can use this ice to cool down the complete buildings connected and bring back energy, heat to the tank system. So as long as we cool the system, cooling means taking out the energy, and we take out the energy, bringing back to the tank. It means to regenerate the tank, the cold tank, the ice tank, heat it up, and to prepare it for the next winter season. So we have 2 points. We are able to cool the building without any energy, or almost without energy. We don't need a machine, we don't need a heat pump, we just need a little pump to pump the cold water out of the tank into the building, to cool the building, to take out the energy. And the same step, we regenerate the tank and we prepare the tank with solar energy for the next heating season. That's the main points about our technology. The first step usually we do is to calculate, to simulate the demand of the plant or of the buildings, of the customers, to know exactly how big the tank has to be. And that's our main point at the first step. The second step, we go to start to build the tanks. It's usually concrete tanks, completely buried in earth covered. That's very important to avoid losses. As long as the tank is in the earth, in the ground, we don't have losses because of the average ground temperature of more than 0 degree. Here you can see a tank with about 550 cubic meters. We built this tank to supply a little village in Gutach. It's a little village about 2 hours away from Friedrichshafen. I can show you the. Sorry, one step between. I will have a look inside of the tank. The most important picture you can see right here. You see the heat exchanger system, and we took out the water to be able to do this picture. It's in the middle of the winter time, around January, February. So the water started already to change its phase to ice, and the ice is growing around the heat exchanger system. So we took about 30–40% of the complete energy already out of the system. About 60% is still left. So it means the water left means there is still energy in the system. What I wanted to tell you is this little village here in Gutach, Schwarzwald. It's about almost 40 single-family houses supplied by this system. They are all connected through a pipe system to one tank. Each house owns a little heat pump and is able to supply with heat and even cold energy. So all of the little houses are even cooled during the summertime. But the main point is for sure the heating during the winter time. The little village runs already about 5 years. So we are in the 5th winter season right now, and we have really good experiences, very low costs for the customers, and no CO2 emission, because we use green electricity to drive the heat pump systems. I want to show you the complete system for itself. We need somebody to operate a system in case of a larger system. You can see here a little village with about, I don't know, 50, 100 or even more houses. You see one huge energy storage or ice tank, whatever the name is, but it's about the same. So sometimes we call it energy storage, latent energy storage. Sometimes we call it ice storage, but it's about the same. The best case is we do have some customers taking out energy, and we do have some customers to replace energy. For example, a sewage treatment plant or a data center or some industry. There are lots of waste heat not being used today. All that kind of waste heat is able to be replaced in the system, in the pipe system. The pipe system can be very long, and it's a pipe system without any insulation, so it's very cheap. Why? Because the temperature of the water, we have pure water inside of the pipe system, and the temperature of the water is around 7, 8, 10, 11, maximum 12 degrees. So we are always around the ground temperature. That means we transport the heat without having any losses. We supply, for example, this house is here with 12 degree water, and supply a little water heat pump here with very high efficiency during the winter time. We are able to use this cold water to supply a data center, for example, to cool a data center. At the same time, we get the waste heat out of the data center. So it's a win-win situation. The data center is giving back the waste heat to the system and gets almost for free cold energy to cool it. We can do it with any other process, for example, milk or whatever the industry is producing, for example, milk or food or whatever. So we can integrate in the system all kinds of waste heat not being used today. That makes it very, very efficient, and we are able to reduce a lot of CO2 emissions. This example shows the winter time, the heating season. I will switch to the next chart. It will show the summer season, the summertime. You remember, during the winter time, we take out the energy and we leave ice behind. So it's clear what we do during the next season, the summer season. I switch to the next chart. Now we have the summer season, and we have tons of ice left in the tank. It means we keep on driving the system with about 10-degree water, so with a cold water out of the tank, and we can leave the temperature at 10 degree, supply the little village with cold energy, supply the industry with cold energy, and use the ice for a very long time. It means for weeks or even months, to supply the complete system with cold energy without or almost without using energy. Just a little pump to pump the cold water through the pumps, through the pipe system, but that's it. We don't need even more energy to cool all the customers here around. Okay, that's the most important points about our system. Thank you very much, and would be happy to hear some questions. I tried to switch back. Okay.
Yeah, thank you, Mr. Rowan. It was a nice presentation, and I have a small question. You just showed us the example of Buda. So what are the sizes of areas you can use the system for? So is it possible to use it for small houses, or should it be a small city or a small village?
Yeah, we're able to supply even one family houses, but it's a question of the costs. As larger the system is, as cheaper the system is. So we start usually at the 10 family houses, more or less, and go up to huge plants.
Okay. And do you have any other things which are not, yeah, let's say it differently. What are the other negative aspects of this technology? Because I think you only mentioned the costs now. Is there anything else which is not so good?
Yeah, not really, no. The costs are the main point. The costs are, the system for itself is one of the most expensive systems on the market, just comparable to the brine system, to drill down in the ground, the heat pump system with the use of earth heat. It's one of the most expensive systems, but at the same time, it's one of the best systems because we don't have any problems with the water, with the, how to say, with the official side of water, for example. So because there is no risk for environment or for the ground, or because we use just water. We use water in the tank. We use just water in the pipe system. So it's a very environment friendly system without other disadvantages except the price. But if you keep in mind about the possibilities we have to avoid CO2 emissions, it will be a very interesting system for the future.
Okay, thank you. But I can also think about the size of this tank. You need a storage space for this tank, some place.
Yes, you need some place, but it's completely buried in the ground. You can park cars on top, or you can even build a house on top. So you don't need really space. You just have some space to you can use later on.
Okay, thank you.
Thank you very much, Emmanuel and Aleph, for this presentation and questions. If there are any other questions, please let us know. Okay, then thank you for this session. We will definitely look forward if others have maybe questions to contact you directly.
Okay, please.
Yeah, thank you.
Thank you very much. Okay, bye-bye. Thank you.
As for next session, we would like to stay in the heat, I would say, or energy storage sector and present the latent heat storage in public building by development agency Synergia. And I think that we have it ready. Thank you, Stefan, for being with us today.
Thank you for inviting me. Can you hear me? Just
yes.
Okay,
yes.
and you can see my screen.
Yes, of course. Yeah.
Okay, thank you. So thank you for my previous speaker. It was very interesting, also related to my presentation. So I will continue with the presentation of latent storages, but the previous was based on ice, and it's all going to be based on paraffin. The pilot project called paraffin-based latent storages in connection with the geothermal district heating system in city of Lendava. This pilot was financed and implemented in the frame of the project called Store for HOC. The long name is Integration and Smart Management of Energy Storages at Historical Urban Sites. So we had to deal with this issue about how to implement storages in historic protected areas, like, for example, in the city centers. In general, just this project was co-funded by the European Regional Development Fund through the Central Europe program. You see the duration, and it's going to be over on the end of March this year. You see the total project budget and the ERDF funds. This is the partnership. We had 15 partners from 5 different countries. But to the pilot. In the project, we had to choose one pilot location, and we choose one building, one old building. It is a Oskar Luppheimer's neo-Baroque villa built in 1906. And it is located in the city of Lendava. Lendava is in northeastern part of Slovenia, bordering with Croatia and Hungary. Just that you have a feeling where this is. So this is a very old building. Now it's in these times is used for as a library, library owned by the municipality. And it was still heated by heating oil. You see the area is quite large, it's 600 square meters, and you see the energy numbers, which was very bad. And the aim of this pilot was to change this fossil fuel finally to a renewable energy source. Also, of course, the reduction of the consumption, reduction of the CO2 emissions, and of course of the cost for heating. And we had to, in the frame of the project, use some innovative solution for this. But before we step to the investment, we have several challenges. As we heard in the beginning, it was in the historical city center. You see the location on the left side. So it is really in the city center, what is a protected area, and based on the Register of Slovene Cultural Heritage, which is under the jurisdiction of Ministry of Culture. the land of a library is classified as profane building. So this means it's connected to several protection regulations, laws nationally and also on the municipal level. We had also several technical challenges of the pilot. We hear before that they wanted to change to renewable source, and Lendava has one of 3 geothermal district heating system in Slovenia, but they have the only one who have a reinjection well. So actually they are the only ones in Slovenia. So of course they wanted to be environment friendly and use this firstly because it's a district heating system, and secondly because they use renewable source. But the problem is, you see on the right side, sorry, on the left side, here is the connections, here is the Lendava library, and on the right side, the blue line is the existing geothermal district heating, and it must be the last connection in the grid. This means that they have quite low operating temperatures, up to 55 degrees, and with the required indirect connection, the flow temperatures will be further reduced by 5 degrees. So the purchase of a suitable storage material was very important in this case. We had also other challenges, for example, the space constraints, small room dimensions, low ceiling height in the basement. Also here, the purchase of suitable material was very important because firstly, we wanted to have a normal water-based tanks, but we didn't have enough space for this. So for all these problems, we finally found a solution in the phase change material, and we use paraffin cells for this. Paraffin cells are innovative buffer storages that have been developed to efficiently store heat and cold generated from small irregular energy sources such as solar or heat pumps, etc. And there are several advantages of latent paraffin-based storages against the usual water thermal heat storages. Firstly, what was very important in our case, requires less space. This means you use smaller dimensions, less temperature loss, so it means it's more efficient, less reactivity with the environment, and less likelihood and leakage as it changes the phase by about 45 degrees. And of course, better heat transfer performance, which means higher efficiency, which means lower heating costs. And this pilot is now unique in Slovenia. This solution was connected in accordance with several sustainable criteria, so on the national level and also on the local level. And last year in 21, in January, we begin with the investment. The whole investment was split in 2 parts. The first part is the pipelining and connection of the building to the existing geothermal network. So that means we purchased 2 times 65 meters of pre-installed pipes and connected this to the Lendava library. We see the pictures, the construction works and the pre-insulated pipes. And the second part of the investment was the installation of the storage system and the PCM material. And you see this paraffin cells below on the picture. We use these sticks for about 2,000 pieces for 2 times 1,000 liter of tanks. And this is the final floor plan. you see on the middle the two tanks, storage tanks with capacity of 1,000 liters. One more shame. This is the final shame with the two storages in the middle. On the right side, you see the connection to the existing geothermal district heating system, then goes to the heat exchanger, then to the storages, and afterwards to the rooms. We installed also a central control system for this pilot because we wanted to test it and monitor it, of course. This is the control panel of this monitoring system. We see that it is in Slovene still, but we will translate this till the end of the project, that you can with link see live pictures from everything what's happening in the storage. You see then the savings, the costs, and so on. We're measuring the temperatures, we're measuring the power, and it's not still the monitoring, it's still running. We have now monitored from April to November. We have results from April till November, but of course it was not the full heating season because we had to stop in May, and then we can continue with the monitoring in October. So we had now some predictions what will be, but after the project we will have final numbers. So with these numbers, what we have, we can predict that it's going to be some reduction also about the energy consumptions in this pilot, and this reduction going to be about 10% due to the higher efficiency of the heating system, of course. Of course, we will reduce the CO2 emissions to zero. We will probably increase the security of the energy supply because if you switch to the district heating, it's more, of course, more secured. And we managed to reduce the average yearly peak powers from 22 to 21. This was the project objectives during the project preparation phase, and if you are looking about the numbers, we overtook them. This was in short for the pilot in Lendava. In the frame of the project, we had 3 more pilot. I will not just quickly go through it, just one slide. We had partners also from Weiz, from Austria. They use a normal water storages, and it was a central thermal energy storage tank in connection with decentralized hot water storage tank. It was connected to a plant with biomass chips. A very interesting pilot was done in Cuneo, in Italy, in city of Cuneo. It was an existing slope elevator, and they realized of a new system for the production and storaging of electrical power. So they put up new PV systems in connection with the storage. And the last one was the pilot in Croatia, in the city of Bračak. They have a old building, a central battery bank system installed of PV systems and integration of it to advance some energy management system. But all of this, you can have more information on this contact. So thank you. If you have some questions, please let me know.
Thank you, Stefan. Just from my side, as Regia is one of the partners that we are now combining in our partnership knows about all of the outcomes, and we also will try to somehow fit our online tools that we develop and see how to fit with your tools, simply to create the synergy. But we are very well aware of the store for huts, and I think that it is a great example of innovative heat storages and other storages. Yeah.
Thank you.
If there are any questions from the audience, please let us know. I think no. Then thank you once again, Stefan. Yeah.
Thank you. Thank you.
Looking forward to communicate with you in the future.
Thank you.
Yeah. Bye-bye.
Bye-bye.
Then we can go and move to the next session, which is Sustainable Energy Factory in Beloslav. So I think that we will try to share
again.
presentation.
I sent you the presentation.
Yeah, just I will now share it.
Good.
It is right here. Okay, wrong. Return it. Okay, yeah. I think that we are ready to go.
Good. Okay. The presentation which I want to show you now, it's about a small factory nearby Varna, around 20 kilometers. And the factory, it's almost energy independent. It's a glass factory. You can see now, look from above. It's a small factory and is specialized in some small glass production, let's say. As you know, maybe the glass factory, it's non-stop process. But in the maybe 10 years ago, it was the first extremely increasing of price of CNG, compressed natural gas. And the factory in that time working with natural gas, but these really high prices didn't allow to continue to work, and they are stopping, which means all process stopping, and it's impossible to start again. So the factory today, it's not only producing, but it's also some kind of museum, and it's possible to visit how was the production of glass 20 years ago, because now it's the system so-called frozen. So that's give the idea to the owner to think some alternative way to for his energy needs. And in 2019, with Norwegian financial mechanism, they make a project, hot recycling of glass waste with renewable energy sources. You can see the project budget. It's 350,000 euro, and almost 240,000 euro was the grant. The next slide, please. The idea is simple, and if you remember how it works, they put as many as possible photovoltaics, and the power installed is 24 kilowatt peak, with, of course, island inverters and 800 ampere charge batteries. So here the goal is to have own electricity production and to have to be covered, of course, with battery, and they switch from natural gas to the electricity for their productions. What is interesting, in that time, 7 years ago, it was really pilot model because the electricity was cheaper, maybe compare with nowadays, around 10 times was cheaper for the industrial. And it was almost impossible to convince some factory to use renewable energy sources in terms of cheap electricity from the grid. But it's actually was a good decision. And as a hotel owner, now he also play with different prices during the every hour, and use all electricity from photovoltaic for all needs. So it's not trade electricity outside of the factory. The next slide, please. Here you can see some pictures. They have big battery rooms with inverters, with management system, and of course the factory inside with all equipment which is necessary for working. So the working shifts are suitable according to the sun energy, let's say. And when it's a hot day, they work. When it's like today, winter time, they just stopping or reducing the capacity production because of the price, of course. And it's somehow example to work according to local situation. But nowadays, maybe from 6 months to now, the factory have really big advantages with this battery system and solar PV generation electricity. And the next slide. Here it's just show how it's connected. It's a pretty normal connection. Of course, energy management system here it's more simple if you compare with hotel, because point of flexibility, let's say, we have more flexibility points where we can manage in terms of the consumers, which allow the factory to be more efficient and more efficient to use the photovoltaic electricity production and of course battery management system. So the main idea is to show how to approach for the implementation of renewable energy sources in different users, and depends on the point of flexibilities, we can propose different different solutions and different solutions which can be really economically reasonable. There is a big space for working with this topic, And I think maybe next decades it will be really booming of such systems which cover all electricity needs. And next slide, please. That's all which I want to say. Thank you for attention. If you have any questions, I'm here.
Thank you, Todor, for your presentation. If there are any questions on the side of applications in the industry and similar approaches, Todor is here to answer.
And very welcome to visit us.
Thank you once again, Todor, for all of your inputs today in those three interesting presentations. We will move forward to the next and the last showroom of good practices, which is renovation of school building. I think that we are ready to go. Yeah.
Yes, let's hope. I hope that you see now my presentation.
Yes.
And I'm not sure if I see the correct. Do you see the whole screen presentation?
Yes, it is on the second slide. Yeah.
Because I see it different. So the topic of my presentation is the reconstruction of secondary school in the Slovak city Trenčín. It's a secondary school for students for work in building industry, and it is in ownership of the not the municipality, but the sorry, I forgot the correct term for the larger region. It's in regional ownership. Sorry, and its original state. So you can see it's a building from 70s, very typical for that time, and really good architecture. So it was very important to keep the original state. But what was necessary to do, we wanted to, or how it was done. First thing was so-called integrated design, where specialists of various professions cooperated already in first design stages. So it enabled also relatively cost-efficient reconstruction in high quality. And there was also emphasis not only on energy efficiency, energy savings, CO2 emission savings, but also on environmental quality, which is especially important in schools where the concentration of CO2 in classroom are very often quite high. And also it was necessary to keep the price, the investment price, so that it was affordable for region, and also look for the life cycle costs in advance, which it's really not common approach in our country. And there was also very important to use energy from renewable sources, where and deal also with architectural quality, also of those energy systems, that they don't disturb the design. And we were very interested in real energy consumption and CO2 emission reduction. So here we can see the result. This is the building after the reconstruction. And if we look on the next slide, here we can see originally it was in the energy class E, what is not really the worst one, but really very bad quality from the point of view of energy efficiency. And it was reconstructed to the class A0, what is the highest degree, which is necessary for new buildings, but for reconstruction it's really not common. And we can see the size of the buildings, it didn't change very much because authors were trying to keep the original design of the building as much as possible. This building has not only the school building, but also swimming pool and gymnasium. And what is quite interesting, investments price was about 70 euro per square meter without value-added tax. What is a relatively low value if you compare it with new buildings or with some reconstruction in West European countries, which I know this was really relatively low cost solution, but high quality, I believe. And the CO2 emission savings goal was to achieve about 200 tons per year. Okay, here are many other numbers which we will see in some tables later. We can see that the predicted heating energy savings were more than 3/4. Reality was about 67–70% in the year when measurements were done. So it's not finished so long, so we don't have too much of data yet. But the school itself, it's even better, and there is some production of energy from photovoltaics, which also helps a bit. And the heating energy need per square meter, it was going from more than 1 hour kilowatt hours per square meter and year to 23, which is almost the passive house level. And the emissions of CO2, they gone down from almost 300 to about 80. So really huge savings. And energy costs, that's not only heating, but also electricity. So there, the saving is a bit smaller, but also very high yet. So there are many other figures about that, which are going to details. I am sorry, I got the updated version of this presentation as a last minute, so I was not able to translate everything, but here are just some pictures showing different approaches which were taken into account. Just a bit of mess, but it was really a very complicated story. And here we can see what was very important: changing windows, good insulation of the building, avoiding thermal bridges. And I am speaking about that because I believe that what is most important in every approach of using energy, renewable energy sources or some energy storage and so on, first of all, we need to reduce energy consumption. And then we have to deal with the problem how to use high efficient systems, how to use renewable energy sources. So this was very important that the energy consumption was reduced, and then, then we were able to cover a relatively large part of energy consumption with energy from renewable sources, where we have some limitations. And what was very important here, because keeping high quality building envelope, it's one thing. Another thing is need of energy savings also through ventilation. So here is, of course, ventilation with heat recovery, which helped really to achieve this high value of energy efficiency, but also very good indoor environment in classes and very quiet environment, where the fresh air is regulation, fresh air control is done locally. And here just some charts showing the comparison of systems of mechanical ventilation with heat recovery. That are those lines on bottom, different versions. It's from Czech Republic resource, not our one, but that line in blue with peaks, it's natural ventilation, and CO2 levels, that red line, it's border of optimum 1,500 ppm, and peaks with natural ventilation were 2,500. So it's really very bad value, which is not good, especially if you have to work somewhere. Here is our own research done by our colleagues from the Technical University in Košice. I don't go here into details, but there were done measurements in existing environment and then a new one, and here are some pictures of this heat recovery system, where also not only the high indoor air quality was achieved, but also quite huge energy savings, more than 4 times better energy efficiency was achieved also thanks to this heat recovery system. Photovoltaic system is only on the part of the roof, so it's not a really huge system. And on other part of the roof, because there is a swimming pool, there is a thermal photothermic system to heat the water for the swimming pool with almost 100 of panels, and it covers approximately 50% of need of energy for heating of this water. Only 50% because in the winter it's the efficiency of this system is not very high, and but the savings in cost are more than 6,000 euros per year. So from the economical point of view, it was calculated that this is an optimal solution. And also, there was also kept natural ventilation for night cooling of the building to keep good thermal comfort in summer month. And here is the photovoltaic system, about almost 120 panels with 31.5 kilowatt peak and 40 kilovolt ampere batteries, and this system, here are some, it's connected to a relatively sophisticated system of measurement and control, which really helps to keep optimum way of regulation of this energy consumption. So here are some pictures from this reconstruction, original state and current state, just to show that yes, it's much nicer now, but also that authors kept the original architectural values. There was no historical monument protection in this case, but it was a very nice example of the late modern architecture of 70s. So authors tried to keep as much as possible in original state. And today, here you can see energy certificate, the highest degree of energy efficiency. And here are some interesting figures. Energy consumptions, we can see that it's almost, in original state, long time average, it was almost 900 megawatt hours per year. It was, and now after reconstruction, or more exactly calculated values in design stage, but reality is very near to that. It's approximately 1/4 of it. In electricity, there is much smaller saving of the needs, just with very good LED lighting system, and also very good regulations and so on. So even if we have more technology in the building, the energy consumption is reduced almost by 2/3, and CO2 emissions came down from 275 tons per year to 76. So that means that almost 200 tons of CO2 savings do we have there, and much of savings of pollutions. I didn't want to put there more figures. It's quite enough, I believe so. And here we can see a long time average of real use and utilization of this photovoltaic system. We can see that the production of energy from photovoltaics covers quite a relatively large part, almost 1/3 of need of electrical energy in this building. And what is important to mention that in summer, when we have really lot of electrical energy, of sun and energy from photovoltaics, these buildings don't need much of it because there are vacations, but it's not worth in our country to give this energy to grid because it's no payment for it today. So it's a bit pity. It has different reasons, and it's one of great problems we have to fight with here, that really enable to sell energy also from such small producers. Sorry, and this is, I forgot to hide this slide. So thank you for your attention, and I will just very quickly show you a quick look. I tried it, but it didn't work, so I will try it again. Sorry. Okay. So here we see it. This is the online regulation, measurement and control system of the building, where we can see now, right now, today, what's the production of the photovoltaic. It's currently charging batteries. There is no use energy for the building is now taken from the grid because it's cloudy, not much of of energy is coming from this photovoltaic system now. But if we look on historical data, you can see here the production of this system. So it's quite interesting that the people which are working with it have up-to-date information of the real efficiency of this system. So that's all from me. Thank you for your attention.
Thank you a lot. I think there are some questions.
Yeah, hello. My name is Yong, and I'm from the Constance Foundation. I just have like a quick question. You mentioned like it was still kind of a problem to sort of sell electricity. Could you explain a bit more, like why is it like a problem to sell it back to the grid in your country? Yeah.
Well, some years ago, if you had a photovoltaic system on your house, you could sell this energy back to the electrical grid, and you get quite nice money for it, even more than was the standard price of the electrical energy from the grid. So you could use the grid as a large battery. You sell the energy when you didn't need it, bought back for smaller money, and then you sold it. So it was very interesting. But for some reasons which are connected with the poor quality of the electrical grid in our country, it was stopped some years ago. And now small producers cannot sell energy to the grid. They can give it there for free. So if you produce more energy than you can store in your batteries, or that you can utilize in the time when sun is shining, okay, you can put it in the grid. You don't have to care what to do with this electricity, but you don't get any money for it, which complicates a bit the economy of those photovoltaic systems. If you want to sell energy to the grid, you have to be a great producer, which is really stupid, because then this photovoltaic electricity, if you have photovoltaic panels on a few thousands of roofs in a city, and there is going some cloud through the sky, it's very small difference in the output of electrical power from this system. If you have some large photovoltaic power plant, then electricity production drops very quickly, goes up very quickly. So it's in reality more problem for the grid than more small producers. But our electrical companies, they don't want to really discuss this. Maybe it will change in future. Also, our electrical grids are improved slowly, not really to the degree of some smart grids, but it's improved a bit. So it will be, I believe that it will change soon, but I don't know when it will happen. And then all those systems will be easier to use and to suggest, because economy will be much better. If we have systems of larger scales, well, on this school it was not quite small scale as on a single family house. And if you can use more of this energy on site, it's much easier. If you can do it on a settlement level, on quarter level, to have some storage there, then it will work very well. But it's very complicated because it needs cooperation of many partners, and cooperation in our country is a foreign word. So
yeah.
I hope you answered you.
Henrik, I would like to add something. My name is Loran Krajčovič, also from Slovakia. there is a problem of storing capacity and a big risk of blackout. The majority of electricity in our country is from nuclear power plants that give us big stability of the system, and such small units could easily cause instability in the systems. So the system stability was the biggest problem issue. Now there are starting such investment of battery capacity building in the Slovakia to have a bigger backup capacity for such cases, to allow bigger infrastructure or photovoltaic installations. So the biggest priority is the stability of the system. Yeah.
Thank you, Laurent.
Thank you.
If there is no more questions, thank you for this very detailed feedback and very and interesting responses. I would like to thank to Henrik and to other who gave us the showroom of good practice examples. Now, after we've finalized all four, we would move to the session dedicated to the regional action planning, which will be hosted by Tiberiu from Alea.
Thank you, Marco. A warm welcome for everyone, and good afternoon. My name is Tiberiu Toma from Alea. I will be presenting some highlights about the regional action planning process that was going on in the CSSC lab projects until now. Let me just share your screen. Okay. Well, I must say that I think I will have a difficult job here to keep this attractiveness of the conference up to the expected levels, seeing that these showrooms and the demo centers with very concrete details about what people do in their countries. Even a non-engineering specific person like me was really attracted to the figures, which of course they are translated into environment, into carbon neutrality, and all that stuff that is linked to sustainability. Nevertheless, I will try to make this 50 minutes as interesting as possible. My presentation is meant to describe the approach of the CSSC lab project related to the regional action planning process. This process is framed in a so-called work package that comprises lots of activities. And so these activities will be in the center of the following slides. I shall start with the listing of the main objectives. The objectives of this regional action planning and Transnational roadmap activity as a whole is to create a strategic framework and a knowledge base on which the other project activities are built on. Then to set up a strategic action planning and road mapping process based on the set out project methodology, and to develop the policy recommendations to bring the CSSC domain and the topics into the real life experience in the cities to enhance their objectives regarding decarbonization and energy security. Well, according to the project methodology, we have in this package 4 main activities. These were thought to be as kind of a road to walk on by the partners and to reach the final objectives of the regional action planning process. We started by elaborating an analysis of existing institutional frameworks and other energy policy instruments to identify the development demand in the whole project area. Then moving on, it was the mapping of the relevant regional actors and their competencies in, especially in the CSSC, but also in the overall energy field. Here, it was meant to be created a relevant practical CSSC technologies database. So some applications were identified on the level of project regions. And not only that, also on the EU level. The implementation of the action planning process comes in third, which is relying on a stakeholders' involvement in each project regions. And this action planning process is consolidated by so-called peer review sessions within the partnership. And the final step in this whole methodology is to elaborate the transnational strategic roadmap on CSSC and the formulation of policy recommendations to contribute to the overall USDR strategy implementation. As from now, I will try to detail some of the activities that have also some subtasks. And you will see what has been done and what will come in the later on in this project. So first, the analysis of the framework conditions and the regional potential for the implementation of CSSC solutions. We did that on a partnership level, and we tried to give information on the development demand of urban energy systems, information on the assessment of the local potential for CSSC solutions. This was done based on the available analyses, regional profiles, and other projects. Then we did a past and SWOT analysis of the regions, of course, related to CSSC. Then we also have realized a comprehensive map of the characteristic of the targeted cities in the project regions. Each project region selected, identified some potential cities to target for the CSSC uptake. The result was that we have 11 regional analyses done, one in each project region. Of course, in this endeavor of ours, some difficulties were faced, but in fact, these were mainly lessons learned. And meaning that, as we saw, lack of CSSC potential in some regions was the case. And of course, there was, given the nature of the CSSC domain and the EU level, but not only, we saw that there is not a wide range, a wide variety of real cases that could be showcased. All this analysis is also linked to other activities in other kind of work packages within the project. Main findings here, we try to be very, very brief here and just name just a few main findings. We saw that there is a substantial difference between countries in the Danube region in terms of current application of CSSC solutions, but also in terms of their potential. It was expected because we have very developed countries, very developed energy sectors, countries who have very developed energy sectors, who also have steady investment flows in the energy sectors. So they have innovative technologies in place, and they really into developing these CSSC solutions. So we expected this, and we also expected that in the eastern part of Europe, where the energy sector is not so developed, there might not be so many CSSC, but so much CSSC potential. However, what we also saw is that political decision makers, especially municipalities, are really willing to uptake in innovative solutions, and this in this endeavor of theirs, it's really hard only because for the main reason of lack of investments and lack of financing. Also, there's a different level of ambition of policymakers at the national level. In different countries, strategies are more ambitious. In other countries, are less ambitious. It was also expected. And from the economical point of view, we saw that the CSSC projects are almost similar, are very, very similar among the countries, meaning that most of the solutions, most of the implemented projects are mainly pilot projects in place, which up until now have seen a low economic competitiveness, but the overall consensus is that this is expecting to change because of the ever-growing uptake of these applications. From the technological point of view, the findings say that battery and thermal storage is of main interest, especially because these can balance the power system due to the intermittent nature of the renewable energy sources productions. Also, innovative applications are more present in Western countries, but this is also related to the how developed is the energy sector. Moving on, also somehow related to the analysis part is the elaboration of the Transnational benchmark study of the CSSC potential development demand in each targeted city. Here, the study is built on the previously mentioned analysis, and its main scope was to provide an assessment of the target cities in terms of their readiness to adopt CSSC technologies. We in this benchmark study, we included the obtention, the status of the CSSC implementation in the project regions, and of course the actual assessment of the target cities in terms of their readiness. For this, a matrix has been developed and implemented in all these target cities. Out of this matrix, we had some really interesting benchmarking that evaluated the CSSC data for the CSSC lab conditions. Overall, it was a great work from each partner, from each CSSC lab partners. We had at the end 19 benchmark cities with readiness indicators. Also, some lesson learned. Among them, there were some difficulties in gathering data for the benchmarking, so this prolonged a bit the provided timeline for this activity, and of course, some challenge was that we found that there is a wide spectrum of CSSC development across regions. Also, this activity is linked to other activities in the project, mainly in the elaboration of the model solutions. The transnational benchmark study yielded some different findings. Here, just a few of them, the main ones. We have to say that we benchmarked some really different types of cities. There was a huge diversity in the targeted cities in terms of types, in terms of profiles, in terms of sizes, shapes, and all other things, ranging from the mid-sized cities from over 100,000 inhabitants to smaller ones, let's say 10,000 inhabitants. Also, the profile was very, very different. Also, the studies show that there's a divergent use of existing technologies. Then that the existing use of city storage involve lots of batteries, battery technologies, pumped hydropower, and flywheels. Of course, also the cities show that there are sector coupling possibilities present in terms of power, in terms of power to heating and cooling, especially in buildings and district heating and industry, among others. All in all, we have to say that the benchmark showed that there's the potential for storage technologies in each city. And of course, there is a need to couple different sectors when it comes to energy consumption, but that is, I think, the experience of all who is involved in some way in the CSSC technologies implementation. The second activity related to the mapping of the CSSC competencies and stakeholders also had two subtasks. One was related to the creation of the translational competence map regarding energy storage technology and sector coupling concepts covering the project regions. We had here a special focus on the CSSC issues based on already existing knowledge, statistical and energy related information. And what we need to say that in elaborating this, a very crucial input came from associated strategic partners and the regional stakeholders. At the end, we had elaborated competence maps structured in regions and also some applications in all CSSC lab countries. All in all, we have 119 organizations mapped and also 35 CSSC applications showcased. The main problem here, the main issue we faced is related to the GDPR. Of course, when you ask for information related to the stakeholders, all need to give some private data, and this is in some cases an issue. But the partners of the CSSC lab find a solution, and we understood the problem, and we provide the handling of the privacy data through the partners based on the agreement they had with the respective stakeholders. The mapping of the CSSC also contained a joint database of relevant stakeholders. Here, as a result, we have a large database with stakeholders involved, engaged, or interested in the CSSC of 169 stakeholder organizations. This is a huge database. These all include municipalities, institutions of the different level, national, regional, and local ones, utility companies, and other CSSC-related businesses, but of course other experts in the field as well. The main problem here also the GDPR-related issue. The solution, as I said earlier, it was to handle data through the partners of the CSSC lab project. One of the main activity of this mapping sub-activity of this mapping activity is related to the creation of the collection of a good practice example. This, as I mentioned earlier in the other activities, there was somehow an identifying activity about the applications ready in the regions. Here, in fact, we deepened this activity and we identified some really relevant good practice examples related to CSSC domain. What I would like to mention here, that this collection of DUPRA is not an exhaustive one. We probably there are probably other more advanced or not or under implementation that was not included here. However, the important thing to mention is that these were selected based on the transferability potential, the impact on the environment, and based on the innovative character. Out of this, we have a result of 18 good practices with corresponding fact sheets. The fact sheets, in fact, are some kind of main indicators of that cover issues such as decision-making arguments, management of the CSSC operation, and the impact-related indicators. As some lesson learned, also we faced some here in this activity. Some good practices are still under implementation, which means that proven final results could not be provided yet. Then one of the main interesting thing was that given the transferability potential of high interest for the partners were some types of CSSC applications. So we needed a way to avoid showcasing similar applications. We all know that a lot of applications with PVs are present, also for battery storage. We identified good ones and let's say the most innovative ones, the most transferable ones, and included in this collection. Also, this collection of good practices is linked to other work packages in the project. It helped to set the model solution, and also it was of great help for the organization of the trainings. They were the basis of some presentations in the training modules. Very important thing here is that all the data and the info related to these, the mapping step and the analysis step is available in the CSSC Lab online platform, which was mentioned earlier by Marco in first presentation at the beginning of this conference. Let's say the main activity, everything up here, every activity converges to this is the regional action planning. So the third activity is the action planning process, which has the scope to provide a suitable framework for the partners to elaborate a consistent regional action planning in each project region. For this, the project was very, very clear. We needed to follow a very comprehensive and consistent methodology. We started by creating the unified framework for the regional action planning process. In fact, it was an elaboration of a methodological guidelines document, and also a package that contains all working documents that ensure a unified approach of the action planning process in all regions. Then comes the stakeholder involvement activities, the elaboration of the regional action plans, the actual elaboration, which in this case is a two-step process, meaning that in the first phase, the partners need to draft their regional action plans based on the analysis, based on everything that was going on until this, the results of the activities until this point, and then the actual finalization of the regional action. That's the second step in this process. And for this regional action plan elaboration, organization of the peer review session is also an important step. This is done at partnership level between project partners. I will be detailing some things about the stakeholders' involvement. The project was very clear on the importance of the stakeholders in this activity, in all the activity, not only in regional action planning. And of course, everything is built on the experience and on the experience of the stakeholders in the regions. So it was very important to have them involved. And for this, the project clearly stated that some organization of events are needed to do this. Why? Because it was needed to identify and discuss the measures to accelerate the take-up of the CSSC technologies, and of course to interact with regional actors and foster the solution adoptions in the cities. How was it done? Every partner had the liberty to do in their own way, in their own specific. So the events were held according to the regional conditions, which to best suit the regional specific. The events ranged from single dedicated events, such as a workshop, to several stakeholder involvement initiatives of different scale, like bilateral meetings, talks, demo session, open days, and such. Even online surveys were handed out by some partners. Who was involved? Mostly, as the reports show, mostly representative of local and regional authorities were very interested in the CSSC, but also companies and universities and research centers were present in a high number. Then NGOs, ESCO companies and financial institutions, architects and other professionals were involved in these activities. As a figure, we saw that the attendance ranged from 20 participants to up to 80, which is a great number, and shows that there is interest in this domain. So, as conclusion related to the involvement, we listed here that the figures show great interest in the field, and the interaction indicates a knowledge, solid knowledge in the field, let's say. But this, of course, differ when it comes to the technological parts, most importantly, especially the innovative solutions. Political decision makers also showed great interest, but their motivation, of course, was other. The fact that they face challenges posed by the energy transition, by the decarbonization objectives and energy supply or security issues, energy stability in the electricity grid. So these challenges all constituted motivation for the political decision making to get really engaged in these events. Now the actual regional action plan, the elaboration of it. As I said, two-step process. This regional action plans will contain concrete actions and measures to bring CSSC solutions into real cases implemented in the cities. The first step was to draft regional action plans based on the data gathered. As I said, every analysis, every activity converged, and the results can be seen here in the regional action plans. The second step is the finalization of the regional action plans, which is due to be done in autumn this year. And what we would like to mention is that this approach offered, stipulated by the project, offered the possibility for the PPs to analyze the identified measures and further adapt and tailor it according to the regional specific, benefiting from the expert advice. So the regional action planning is a process that let's say enlarges on a greater period of time. A future step related to the elaboration of the regional action plan that comes in the following months in the project is the organization of peer reviews at partnership level. Here, I would like to just mention that this is done on a partnership level, as I said, between the partners. Basically, expert partners will help support the less experienced partners in the field. There will be further analysis and further input given to the identification, the adaptation of the measures in the regional action plans. And then this activity will end as a closure with a workshop in which joint analysis will be presented and probably further discussed among the partners. As a future activity also is the elaboration of the transnational strategic roadmap. What we would like to just quickly mention here is that the regional action planning process is the basis for the elaboration of the transnational strategic roadmap, and the roadmap will build on the actual regional action plan. So this need to be ready as quickly as possible to have some kind of input for the roadmap. This will also involve, beside partners or stakeholders, all involved parties in the CSSC lab project, and that the roadmap will contain the policy recommendations to contribute the USDR strategy implementation and national urban energy strategies in the Danube countries. This is more or less about the so-called work package, the bundle of activities that cover the whole project in terms of time. And if you have any questions related to the methodology, to I don't know, the findings or other things that still are unclear, we can answer here, or of course we state our availability to answer it in an email if you feel that it will be the right approach. This is said, I thank you all for listening, and Marco, you have the floor.
Thank you a lot. According to our agenda, we are in the next part of the break room sessions. So I will move you to to your break room sessions automatically based on your responses and availability now on the meeting, because some of the people are not here. So we will proceed in those in around 15 to 20 minutes. Each session will contain will give you certain aspects of this project with the aim of getting your I would say feedback in online polls or any other session. So it is 20 minutes dedicated. If you finish earlier, just let us know. We will after 20 minutes you will go directly back into main meeting. So I will now open all the break room sessions. Just a second. I think that we can start with first break room session. Thanks you for joining in this session. More on the organization of activities related to regional action planning in Croatia. Just to share the screen. Okay. I think it is okay now. Okay. So as I showed this in the previous my first presentation, it is, and now Tiberio explained you the whole process. I will shortly present the outcomes in Croatia, so regional potential and benchmarking studies, and then outcomes of our regional workshops, all with a plan of giving you some concrete examples of how you can do it regarding the regional action plans, how you can do it in your countries. Just to share on the presentation. So as I mentioned, we are doing it for the Zagreb County, but for our initial potential, we went for the something called Urban Agglomeration Zagreb, which is basically under the Integrated Territorial Investments Mechanism from the European Commission, simply a way of organizing counties and organization structure within the Croatia. This is the biggest one, and it has around a quarter of total population. If Croatia now with the new statistics even higher. And for the city of Zagreb, it really maybe not in the terms of a population, but in the terms of GDPR, it really holds the I would say the most of the development. Regarding the energy efficiency, energy savings, and renewable energy, there is a lot of ongoing projects and already finished projects of public buildings retrofits, LED lamps, and photovoltaics, just as we saw now in previous sessions. Electricity is produced with the 2 thermal power plants, which are the basis of our energy system in here. And one is cogeneration, one is thermal power. And there are several cities which do not have district heating systems. In this, only 4 has, so other has individual heating systems, mostly on natural gas with no exact usage of biomass. As for some potential, we are have ongoing 3 projects of the solar thermals that Regea participates as our collaboration, and there is also one small hydropower plants in the city of Zabrze, which is in plan. On the other hand, there is a lot of small-scale projects of PVs, as I will go and back and mention that later. There are 3 targeted cities, as I said, and all of them has some documents which they were created before, such as SEAPs or SECAPs, and some documents that can be related to CSSC, I would say, initiatives such as batteries or heat or ice storage and so on. So they have something in the development, and it is a great way of doing in the 4 biggest cities in Zagreb, Samobor, Zaprešić, and Velika Gorica, since they have very well developed system, district heating system. As for benchmarking study, as Tiberius said, we have went through the each city and gathered the potential. So here is some
specifics of the city of Zaprešić, which has a pretty high potential due to very well developed grid, electricity grid, and also for district heating, which is developed only 20%, but in the area which is very highly dense populated and can cover a lot of heat demand. About 15% of local consumption is provided from renewable sources, which are various, and there are 2 public charging stations which are very well relevant for this vehicle to grids and batteries. There is no electric buses, although there were several attempts to introduce them, but since I will mention that later, on some documents you need a higher instance of the governance, it was stopped. As for our regional workshops, we have had a very quite interesting workshop on December last year, where we, in collaboration with our Zagreb County partners, organized event for 32 people, and 4 main areas were identified, something called integrated climate energy spatial planning, which is basically creating heat maps, heat zones, and integrate all of the strategic documents into one platform. That is what we are doing in the city of Karlovac. The other one is aligning of our energy efficiency action plans, which we have to do as a public body to reflect on the energy efficiency, rational use of energy, and so on. The third one is what already was mentioned in some of the presentation, is a smart village or smart city concept, which is very applicable in all of our regions, especially in mid-sized and smaller towns, municipalities, which basically puts importance on the smaller areas and not only on the urban areas. The lastly is something that we are developing throughout, I think, so far 7 years, is the decarbonization of heating systems in the city, in the Zagreb County. Some larger scale projects of district heating and how it can be maybe implemented in our work in CSSC. As I said, workshops and all the other data gathering, they were the basis for our draft of regional action plan, which is basically very similar to a lot of other strategic documents, and that is why it can maybe be a little bit tricky to do it. But in short, we need to highlight the measures that are somehow favorable in our environments, such as PVs, not only on the technical side or on the financial side, but also on the sides of organization and proper handling of the documents. That is why we have developed for the city of Karlovac something that was, I think, shared among the partnerships already, is the integration of SECAP measures into spatial and zoning plans. So basically what we are proposing for the cities is a new guidelines for spatial planning, where to maybe ban the natural gas or where to favor the photovoltaics and so on. Everything is of course based on the analysis. And in terms of implementation of CSSC technologies, the same approach can, as I said, be used for the PVs, heat pumps, various storages and chargers. Currently we are estimating the possibility on calculating where exactly the charges should be for some public routes and so on. So it really gives you the interactive planning on city level. The second one would be the energy efficiency action plans, which are plans for basically in Croatia which define which buildings has to be refurbished, which buildings has to go and has the natural gas and heating oils or use any other energy. In other words, it is basically gives us an overview of the whole building sector, which is very good, since we can use these documents to prepare ourselves for new financial funds and prepare and give us the overview of just a second. I think that something is wrong with one of the sessions, so I apologize. Just give me a few seconds. Assign partners. Sorry. I think that it should be better now. I don't know. Something is but I think everything is okay now. Yeah, just to share the invite. Okay, sorry for this. I will continue with the slides. The third one is actually the CSSC applications in the smart villages concept. Basically, everything that you have seen so far, the digitalization and the whole advanced monitoring tools, how to integrate them in these sessions. Especially this is important for the urban and rural areas, since there we can combine energy sources and maybe agriculture and other aspects which can provide us. This smart village is not only on the smart sensors or infrastructure, but also on integration of integration of education and boosting capacity building and raising awareness, so to let people know that they can also be in the focus of these changes by their own initiatives. Lastly, is the development of the decarbonization and decarbonization of district heating systems, since it was a very long-term process. It involved several EU projects and a lot of meetings. Basically, what we want to show you in our demo center is that it takes a lot to plan large-scale systems, especially for the solar thermals, but they are more feasible if they can be done. And why is that? Simply because there is a larger, I would say, larger need of the heat if the system is bigger. So that is why our district heating company, on the one hand, opted for the solar thermal, but on the other hand, recognized that they need to expand their measures, and that was, identified on the national level. So now we have to, until 2025 and then until 2030, prepare plans of how the system will be developed, where these public pipelines will go, and who will have the possibility to join. And that is maybe one of the requirements for this interactive spatial planning. So as a measure. That is 4 things that we have proposed in our documents. We are happy to share with our external participants today, simply to give you the touch of what we are trying to do, but not only to stop on the measures.
We, of course, need to finalize them, and everything is now still in the concept. So basically, we will do a typical finalization of the measures, put some time frame and budget, and actually talk with authorities such as you about the implementation. What we usually do is to link it, and it is a good practice in all countries, is to link it with the available national and EU financing. In Croatia, currently, it is National Recovery and Resilience Plan and operative programs. I'm sure that you are very familiarized with those. On the European content, there are several initiatives and parts that can be related and studied more in details. We, of course, already mentioned European Green Deal, but on the other hand, we have operational programs for ESIF for this next period, also modernization fund and innovation fund available in several countries, which can give you the push for projects such as we saw in previous sessions. Lastly, there are projects, of course, such as EU projects and programs where we simply have initiatives such as this one. And lastly, I would go with three short questions from your side, or simply to share with you the online pools in the chat. Sorry, I think that this is now okay. You will be able to see it. So just go on this slide and type this code, which is on the on the screen, and then you will be able to go on our slides. The first question is, which measures are of interest of you as involved stakeholders in regional action plannings? So just sorry, I think that something is troubled. Sorry. I think that it should be okay now. Sorry. Okay. I think that it should be visible now. So if you can vote on this slide.com with this code, we will soon start seeing your answers. Here are the responses. So just take your time and let us know which. The code is 928381. It is shown on this screen. So if you could type the answers. I don't know if we have some problems. Yeah, thank you.
I think that some of you provided the answer. So the answer is measure 3, which is definitely the smart village. And thank you for that. I think that our time has passed, so we will just return to the lobby in the midterm conference. Thank you. Hello.
Hello again.
I hope that these break room sessions worked, that you were able to present and discuss about these sessions. So just to go in short for the first one, that we have gone through the regional action planning process in Croatia, how we do it, and 4 measures that we prepared. And based on that, the most important measure was the smart village or smart city concepts, which can greatly be fit in the future for integration of the CSSC. I don't know if anyone else from the second and third sessions would just give us a few sentences, and then we can go on the next session.
Yes, just a short feedback from our room for our discussions. We got from Michael a short but very comprehensive and interesting presentation about the history of their network, how they are get and work with stakeholders there. It's not a result just of one project. They have a network built up more than a decade, and they're in a very good cooperation and strong cooperation with 10 municipalities in the region in a foundation, and also in a project or in an initiative, innovation lab, that is Act for Energy, partnership with the companies. Also, we got from Florin from Alea also an interesting view how it works and how people are interested in Romania, especially in Alba Iulia. So these were our discussions. Thank you.
Thank you. And in the last one, in the applications from Dimitri, I think.
Yeah, I'll just share my screen. Thank you, Marco, just to show the results of our very short and brief discussion. We discussed several points of interest in the implementation of CSSC solutions. And as you can see over here, we had different topics. On the one hand, the technical requirements that are important to ease the implementation of CSSC solutions, with different answers from the participants in our breaking session, where they all focus on the energy audit and energy management importance as one of the main points. Also, in another color, the financial requirements that were important for the implementation was the support for all scale solutions. This was a comment of Henrich that also mentioned that there are in their country there are a lot of or there are also solutions for financial purposes for very large or small scales, but not for middle scale solutions that fits more to municipalities. Also, we discussed the importance of funding and legal requirements, and we were all d'accord with the point that the bureaucratic procedure should be as easy as possible, also to allow other stakeholder groups to be part of this implementation process. or the implementation of CSSC technical solutions. Low barriers help, and regional advisors and technical help, like different local points of context where people can receive some information about what they are planning, but also how to proceed. Like the CSSC lab also is thinking of it in the demo centers. Help, this help would be very important in the implementation. There are more general factors that can be considered by the implementation. On the one hand, of course, it's the general acceptance, but also the low costs that should be considered by implementing a CSSC solution. And also what is one maybe more German point of view that my colleague Jung mentioned is that all these solutions and projects also have a high priority for climate and environment, and that this should also be communicated to the general public. We didn't mention so far, or we didn't discuss the stakeholder, because this was one thing that was discussed in another breakout room. So thanks a lot. And this was our results from our breakout session.
Thank you a lot, Dimitri, and thank you also to Cosmin for very insightful feedback from their sessions. As you're probably aware, we are kind of late with our schedule, so we will shift to the next session and the last session today on the topics of technical and financial modules. For that, to give them more space, to give them at least half an hour, we will exclude these online pools at the end, and I'm sure that we will get in touch through your everyday work throughout the network of partners in future steps. So Roman and Cosmin, the floor is yours for the overview of trainings.
Thank you, Marco. Okay, let me just share my screen. Okay. As you know, CSSC Lab provides a comprehensive support for cities in regard to energy storage and sector coupling. Beside the model solutions we are developing and the support, our support for action planning, as we heard in one of the previous presentations. We also provide a comprehensive training program to raise the knowledge and capacity of city actors, in order to accelerate the investments in this kind of solutions and the expansion of energy storage and sector coupling. Today I was about to go through the capacity building program that was developed within our CSSC Lab project, to go briefly through the topics of our trainings, the local activities, and provide a brief summary of the training models. And in the second part, Cosmin would present the financing training models with an outlook to the local advanced trainings. So now, as Marco already said, we are running a bit late, and I was thinking about to adjust a bit my presentation and skip the brief presentation of the models, as it was most of my presentation was already presented in our other events. And as I saw, it's getting late. People are getting tired. It's hard to stay focused, and I would propose to make the focus on the next presentation from Cosmin, and which is actually connected to those training modules that have not yet been presented, and with this outlook to the advanced trainings that we'll carry out in the coming months. But anyway, just a couple of words about our work in general. The main goal of our training program is to build up local capacities of city administrations, utilities, and other relevant energy project developers in regard to urban energy storage and sector coupling. And by implementing these different sets of trainings, we aim at creating a continuous level of interaction between us, the project partners, and the cities from our regions in order to facilitate the development of concrete projects in our target cities based on the results of our project. So to raise local capacities, CSSC Lab provides 3 sets of training formats: local basic trainings, creating a general understanding of sector coupling and energy storage, and to set the ground for all future activities. The next level are local advanced trainings to deepen and upgrade this gained knowledge from the basic trainings. And in practice, we aim to provide in this basic training just enough information so that participants can brainstorm and develop concrete ideas for their own situations and own local cases. And in the advanced trainings, we will have the possibilities to focus on these concrete proposals and work from there on. The focus will be on the economic assessment and financing models for CSSC projects, and Cosmin will give more information in his presentation about these training modules. Well, the last set of trainings is a complete individual approach where partners in bilateral coaching sessions supports the interested city representatives in the development of such concrete CSSC projects. The pilot local trainings, our program started in October and will take place until September. In 4 countries, local trainings activities are already begun. So far, the trainings have been organized both in person and online, depending on the local situation and the individual decision of the organizing partner. It's to expect that most of the trainings, at least those in winter and early spring, will take place online, and therefore a set of materials for online trainings is being prepared. The package will include instructions, propose online training structures with breakout sessions, exercises, and short tests. Well, as you already know, for the purpose of the local training, we developed 8 different training models around sector coupling and energy storage. The models have been developed in 2 ways based on already existing training materials and adjusting them to the topic. And on the other side, as the topic is in some aspects still relatively novel, we developed some parts by starting from scratch. Well, The modules are divided in two parts, covering the technological aspects and economic and managerial aspects of CSSC. As you can see on this slide, the modules are covering energy storage and sector coupling, heating system, electrical system. We will enter the fields of emerging CSSC technologies, provide basic understanding on macro and microeconomics, and we will address economic assessment of practice examples and provide concrete financing solutions for investment projects. So I will stop with my presentation at this point. That was really a brief review of the training program, and well, I would like to invite you to join the local trainings in your region, and especially to support us in the promotion of the training activities. And now I would say that we just move on with the next presentation from Cosmin, who will give more information about advanced trainings and the financing training models.
Okay, thank you very much, Roman. I think, can you see my screen?
Yes.
My presentation. Okay, thank you very much. So I want to start, and just to go on with my first slide, and I want to say it was a little bit hard to try to put a lot of information in a very few minutes, because we intend, and the main goal is that we will organize a train of trainers in a webinar where we can then present you all the training materials regarding for advanced training sessions, especially financing, what is my presentation now, because there is a lot of information, and we will go then slide by slide, and then we can also give instructions to the trainers and to the future trainers, and of course more detailed and more explanation. So as Roman mentioned, here we have these training sessions are planned for April to September. So we are can tell you that you will have all our support in the preparation of these sessions, and in the explanation about the training materials, and also the support for this, what it means, references or additional information for trainers. We have prepared how Roman mentioned the last two modules on economic assessment of practice examples and business models and financing solutions. So we bring here in these materials also knowledges and experience from another project developed by Complus Ultra in the last 2 years. It's an Horizon 2020 project named eFix. And it was very well related to our goal here, because there have been analyzed and tested innovative financing mechanisms. So how I said, I'm going to present you just the structure of the training modules, not to go slide by slide, because there are a lot of slides. I want to present you the structure, also bring in screenshots from slides, from information, to give you an overview on how we structure and how we think to proceed with these trainings. And of course, at the end, please don't hesitate to ask me questions, and I will I can give you the necessary information. So we structured the module 7, the economic assessment of practice examples, in 2 lessons. The lesson 1 is the evaluation mechanism for investment in energy efficiency. and then an economic profitability calculation. Here we think, and I want to mention now that it's very important for the future trainers to adapt all these materials, what we have put in the training modules, to adapt this information to the needs, to the interest of the participants in their sessions, and also of the level of the participants. Because we are putting here very special, and it's not too low side that it's an advanced training, because we have very specific and technical information regarding financing and calculations. And we are prepared also calculation tools and examples how we calculate or examples for project. Also in the second module, in the module 8, business models and financing solution, we have here more information. So we need here to organize in 4 lessons, because we want to bring information and to give the knowledges to be helpful in analyzing and in finding a solution for financing. So we are going in the lesson 1 of project financing, because we are talking not about corporate financing, we are talking about complex projects. We are looking to energy performance contracting, like also an alternative solution of financing, also crowdfunding, an innovative solution, and leasing. We are looking here to provide the necessary information to train the people to have the necessary knowledges. So starting with the lesson 1 in the module 7, we have the evaluation mechanism for investments in energy efficiency. We try to cover the evaluation of energy efficiency projects, because the core of our CSSC projects are looking to energy efficiency. And this is very specifically. Also, we are going to evaluation methods and examples. I hope that you can see my screen. Also, I said there are screenshots what we are looking to present in the training materials. You are going to ask why energy efficiency evaluation, why it's needed, what is necessary for the investing businesses, for financing institutions, equipment providers, but also going then further and to look how can be evaluated these projects from different perspectives, because you need first to evaluate the projects, and after that to find the financing solution or a financing method. So we go further in the presentation and bring financial evaluation methods, where we have no specific methods such opportunistic, undiscounted methods, but also discounted methods where we are going exactly mathematically to present how net present values formula is working, how also an IRR and an internal rate of return can be calculated, focus on energy efficiency projects, how you can apply this, how you can analyze the results here, and of course also other parameters like leverage cost of energy, and they are a little bit more complicated, complex calculations, but they are very useful in evaluation mechanism for the investments. Will be helpful for the people, because we are looking to the participants. We are mainly coming from municipalities, and they are going to think about projects. And when a question is coming, how we will finance this, wow, we go to the bank. No, it's not only this. How I know if it works or if it not works? After they have looked to technical specification, they have to look to financial method and to financial calculation. These are just basis on calculation, how they could be done and how they could be analyzed, and the results to be analyzed. We have here prepared, just to mention also here, to all these formulas, what we have, we prepare also Excel tools where the trainer can use these Excel tools to make practical exercises with the participants, to put in the values, and after that to see how the results are looking, and to discuss and have an interactive presentation and study and learning session together. After this preparation in the first part of the module 7 of the economic assessment of practice examples, in the lesson 2, we are going on economic profitability calculation. And we are looking to a simple Excel tool for economic calculation. And we choose also from a project where Con Plus Ultra were partner. Its name is CamProfin. It's a tool developed here that for energy efficiency projects, and are not. It's an easy tool, but you can use it and you can look to the results, and the orientation proposals are only and are not to be considered as an evidence or an expert opinion. But it's a first calculation for people who want to say, okay, how it looks, how could be the outputs of my investment. Yes, we will provide this tool in the training session. We have also a link. The tool is in a very easy form with instructions to fill in, to put the general data of measure, to also bringing the cost, taxes, all the assumption about the planned project. And after we have put it in the sheet, we have here the possibility to choose from different sections like photovoltaics, electric mobility, or biomass heating plant, storage, wind power, other projects, where we put technical data, also financial data in, and we have with some more calculations, other results, and we have here, you can see results as cash flow, present value cash flow, net present value, IRR, equity, and also at the end I show an example for 1.5 megawatt peak PV system, and this is can be also used in the teaching lessons. So this was the lesson, the second lesson. This was economic assessment of practice examples. In the module 8, we are looking to business models and financing solutions. So we are looking about overview presentation, a short presentation regarding general financing methods, and with after that with focus on project financing. Because you are not looking to corporate financing, because you are looking that we are talking about municipalities. They are going to develop projects, different projects in different areas. So you are looking to present how project financing is working, to look the common risk in complex projects, also bring managerial recommendations, and also practical examples like in risk mitigation, but also example of projects, implemented projects. We prepared here in the materials a lot of information in the notices of the slides. They could be useful and will be useful for the trainers, for the future trainers, to get more information to prepare themselves in the teaching lessons. So going further with lesson 1 in the module 8, project financing. We are looking to financing method categories. How I said, present a typical contract structure of project financing deal, giving an example like a heat pump concept by Najidul Amze, Also, risk management is presented in detail, the steps and recommendation and importance of what means risk management. We try to look to the main figures, to the main components in analyzing and financing a complex project. Further, we have the lesson. In the lesson, we are going to financing possibilities. One of them presented also, how I said, we have focused on these three main financing possibility. One of them, and the first one presented here, is energy performance contracting. We are looking here to arrangements, process, financing, risk, challenges, conclusions, to give an overview what it's important when we are think about an energy performance contract. Why an energy performance contract? But because it overbridge barriers between investors and project developers, also bring banks and financing people with technical people together, and also they share a main part of the risk. Yes, also presented different schemes and structures on how an EPC is working, how the key actors are involved in such a structure, in such a contract. For sure, we are going further and in these lessons and detailed and bring information regarding the EPC process. What are the decisions? How are the time frames planned and looked like? Also going to see how are the cost savings in an EPC, how you can plan it, how you can, because there are a lot of possibilities, and it's very important to choose the most adapted and that fits in the needs of the investor. Also, looking, how I said, we are looking about risk mitigation, but also how we transfer risk of energy performance and also transfer the risk for financing. Innovative financing solution is crowdfunding, also detailed in our training lessons. Is also a very innovative new financing scheme and mechanism also in many countries, also in Austria. And we are going to present how crowdfunding could be or not could be. It is a co-financing method. Also the relevant actors, types of crowdfunding, the benefits, how you have to proceed, what are the phases, the process, the risk associated, of course, and what are the energy benefits using crowdfunding. Yeah? Crowdfunding is the practice of funding a project by raising small amounts of money. It started now in Europe. It's an alternative finance method. You are looking at there are crowdfunding schemes with non-financial return, with financial return, and we are going to bring details and to bring instruction how you can consider crowdfunding as an option in your financing solution. Yes, we can see how the steps are. Also, what are important considerations for the success? Not last, we are going to present risk associated with crowdfunding, like unclear taxations. Also, the whole process, like I said before, regarding the process and the steps in crowdfunding solutions. Here we bring also examples, detailed, and of course the calculation tools, the Excel templates, what we present with formulas could also be applied in calculation. What does it mean, crowdfunding, like to see the interest rates and how we work with them. The last lesson of the modules is leasing. Leasing, yes, is an option, is a financing solution, is common. Or yes, of course, everyone's know about how you make to make a leasing for a car, to buy a car in a leasing system. But we are looking to energy efficiency. We are looking to the complexity of this. Projects and how we can apply a leasing solution. How does leasing works? What types of leasing are? The leasing evaluation and the benefits. Very important here, and what we are looking for is the leasing evaluation and how you can calculate this. Yes, we are looking for the three main types of leasing: operating leasing, financial leasing, lease or sale and lease back. But also short presentation, like not very usual leasing schemes, just want to present it shortly, like synthetic leasing or other kind of leasing. But these are the main types of leasing what we are looking to present and to bring the knowledges to the participants. As I said, very important is how we are going to calculate, to evaluate a leasing. If we can perform with a leasing, if it's a good solution for us, for who is the best, is this good for the leaser or it's not good for him, and we are going to do this by bring the knowledges regarding to a calculation of a net advantage to leasing. There are formulas. We have prepared example and calculation tool where the trainers can involve actively the participants to make an own calculation, to present an example, and to make it interactive. So the goal at the end of the training session is that they could go home and said, okay, I know to make a calculation. And I think this is very important and was one of the main goals when we have prepared this materials. Of course, some benefits of the leasing and details what are usual, and open the discussions to the participants. So this was from my side. Very quick. I was a little bit in stress with the time because, how Roman said, we have not so much time, and I don't want to waste your time. But so very, very quick, a lot of information, and I think it was clear. But don't hesitate with the questions.
Thank you, Cosmin. That was an excellent overview of everything, basically, what will be there for our partners and their regions in this last, I would say, 2 periods of our project. I think that there is one question of if it's possible to provide lessons in text and not only in the pictures, but I think that all the texts are already on the Google Drive. So we have all these lectures already there on the Google Drive. So we'll make sure to share it. From my side, I just wanted to say that these advanced sessions, which you just saw, will be done in collaboration with expert partners. Some of us will organize with other countries meetings like this to discuss, to develop more into content. And of course, once when we have the online tool, everything will also be much better understandable from this point. I think that, yeah.
I just want to mention what you said now, that the training materials we are prepared in collaboration with Leas, with Roman. They are presented in form of PowerPoint presentation with notices and references with instructions to references and additional information materials. We have not a documentation, a book to describe all this. It's very, because it's hard to know what is the level of the knowledges of the participants. But I think we are also going now to prepare the online versions. And of course, we are going to prepare and to organize this webinar. And in this webinar, we are hope of large participation. And here we'll summarize all the inputs from the participants and all the recommendations. And of course, we are open to improve our materials and the lessons until we can say, okay, let's take it. So they will all the materials on the Google Drive and access them.
Thank you.
Thank you.
Thank you. I think that there is also a question from Dimitri.
Yeah, Cosman, just because I'm curious about the thing you mentioned about the crowdfunding. What are you thinking about the future potential of crowdfunding in these type of projects? And how do crowdfunding financing models fit with, or which kind of business models for running these CSSC solutions, for instance?
Yes, a very good question, and thank you for this, because if you look to the figures, I think at the first look, someone can say, wow, it's too expensive, it's not for me, why I'm going to do crowdfunding, to choose a crowdfunding solution and not a bank or some other funding schemes, European funds, and so on. It's not a simple solution. It's not one solution. It's not a one solution to be applied in the financing of complex project. But I think for us, for CSSC projects, the main achievement is now using this kind of solution are not the financial achievements or the financial advantages than the non-financial. And I look here to the possibility to involve the citizens in this action, to bring them as participants in such complex projects, because we are talking about municipalities. Municipality has also possibilities to go to the bank to access different funding schemes and so on. But I think it's very important, and it's very I think it will be very interesting, the presentation during the session, to show that here we got the results, the advantages by have social, environmental results and benefits, and not financial, because we are go to increase the awareness of the population in such projects, to bring knowledge there through such a kind of funding. And municipality is not depends on these small amounts what they can bring, but they bring the involvement of the population, and this is very, very important. And it's not a financing solution; it's a co-financing solution.
Okay, thank you for the clarification.
And all of this, I can I bring it, and it was what I said before. We have the experience. Also, was our main target and main task in the eFix project from Horizon 2020, and we studied this solution application in pilot projects. It's not an easy solution, but it's a very interesting, and I think it's good to be mentioned and to bring the knowledges to people.
Yeah, I just thanks for your clarification and your information. I just share a link from a partner of us, and also in a crowdfunding provider. And I think another potential is that these types of co-financing, as you mentioned it, opens also the door for European financing programs, where different partners from Europe maybe can, or people can join good ideas. So
yes, and what I want to say, and for energy efficiency project, because CSSC projects are energy efficiency related, the bank, the specialists from the bank, they don't understand the benefits from the energy efficiency. They look, okay, I want to buy a car. Okay, this is the car. What are you doing with the car? But how it works. Where are your savings? And this is the reason. Okay, we have an EPC and we have the savings here. What are the savings from an energy performance, from energy efficiency? And this is very hard to finance such energy efficiency projects. And at the end, CSSC projects are energy efficiency related and very hard to understand from the bank specialists who are giving us the money.
Thank you.
Thank you.
Thank you a lot for this discussion. I don't know if there is any other questions on this or reflections. I'm sure that it is very interested to all of us to seek for crowdfundings and mobilize private stakeholders and locally based people to participate in these projects, especially in the energy communities and so on. But that can be a topic for itself. Yeah. So without any further, we are already way above our timeline. So at the end of this, I think 7 hours session, we just want to thank you on behalf of the Regea and the whole project consortium on your time, on your showroom of good examples, practices, and break room sessions input. So we will make sure to give you a proper follow-up with the recordings and PowerPoints in after during the day. So thank you once again for your input, and we are always here for all the questions that you have.